Good evening, student. Okay, last time we were discussing question based on blocks connected with the spring. Okay, and this is the homework that I had given to you. So you can have a look that what is the question here. 10 kg and 15 kg is connected by a spring having K value as 100 Newton per meter and 20 Newton force is applied to left hand side. So it appears that 20 Newton and 20 Newton, okay, if both forces are applied, okay, in the same direction, maybe compression will not happen or, okay, elongation will not happen because same amount of force. But this is not the way to solve the question. So before I could solve this question, whatever the theory that I had discussed last time, I'll just repeat it little bit, okay, and then I will try to solve this question. So last time I have explained that if I'm taking any block of mass, say M1 connected with M2. So all the possibilities I will give you here, okay, and then I will discuss this question. In between you can solve this question also, that if M1 and M2 is connected by K and here the force applied is F2 and this one is F1, okay, then what is the extension in the spring, okay, or individual extension of mass M1 and M2. So you can recall that if the force is applied both sides, okay, then what is the effective, okay, elongation in the spring or compression in the spring. Here clearly elongation, because both forces are equal and in opposite direction, so it will pull the spring, okay, apart in this case. So what is the total force, okay? So you can have a look that here force is M1 F1 and this side F2, but effective we have to find out what is the extension total. The extension total is given by 2 F effective. You can check my notes, by K. And what is F effective? F effective is given by, okay, because this kind of questions appears to be very complicated, but if you know certain step you can solve it mentally also. So here is the things. Here it will be M1, just cross multiplication, this mass then this force, M1 F2 plus M2 F1 upon M1 plus M2. Okay, so this will be, okay, in this case F effective, and then you need to substitute the value here 2 effective by K to know what is the total extension. Soon I will tell you what is the individual extension or compression in this case. So is this okay? Now question become little bit tricky once this direction of force is being changed. So once the forces are in the opposite direction, there is no problem. Even the forces are like this. See, I am just changing little bit. Can you notice that direction of F1 has changed now? It has gone to your right hand side and this is left hand side. So in this case both forces are opposite to each other, so they will compress it. Okay, so again this will be the F effective and then this will be the X is called now compression in the length. So this is the way to find out. So these are two easiest case, okay, I told you. Now let's see the most important case, that if the forces are in the same direction, like here 20 Newton and 20 Newton, it's your in left hand side, right? So what will happen if they are in right hand side? So this kind of questions is quite important. So that's why I had given as a homework to make it very clear that what is happening here, compression or elongation in this case. So have a look. So if I am changing here a force F2 and F1 in the same direction, then what is the value of F effective here? So here F effective will go like this, M1 F2 minus, because they are in the same direction. Whenever they are in opposite direction, whether it is compression or it can say elongation in this case, okay, this will be plus sign. Here it becomes minus M2 F1 upon M1 plus M2. Now if this is dominant, say M1 F2 is more than M2 F1, okay, then extension will happen because this is more, so it is going to your right hand side. So the magnitude of this, if this is more than this, it will be, okay, elongated. If it is lesser than this, it will be compressed. So this is the way to find out. M1 F2, if this is to your right hand side, you can have a look. If this quantity is more than M2 F1, okay, then if F effective is positive, that means extension is happening. If it is, if M1 F2 is lesser than M2 F1, then it is the case of compression. Okay. So here what is your opinion? Okay. So similarly here also, if I am applying a force here and this side, so if I am applying the force F2 and F1, this one, okay, then what is the case? Same thing, M1 F1, M1 F2 minus M2 F1 upon M1 plus M2. Okay, expression will not change here. If M1 F2 is more than, okay, M2 F1, then compression will happen because it's along the spring, this force. This magnitude is along the spring, so it will compress it. So by this way you can know that whether it is compression or elongation. Again I am repeating, if this F2 is applied, if M1 F2 is more than M2 F1, if this quantity, and you can see that direction of F2 is along the spring, so it will compress the spring. If it is lesser than this and say this quantity becomes negative, then there will be elongation in the spring. So these are the 4 cases I have discussed last time at the last moment, that's why I am repeating it. Okay. So if this clear, you want to ask some question, then you can try this question, whether it is compression or elongation in this case. Similarly here you compare it. Okay. In between let me read your messages. Okay, so Jaguel has given answer, it is 0.08 meter. Okay, let me have a look. 0.08. Okay. Okay, so have a look here. What is the answer for this question? Here both forces are in the same direction, so it could be case of compression or elongation depending on cross multiplication. So I am going to solve like this. This is 15, and so here F effective is given by, okay, 15 into 20, 20 is your left hand side, minus 10 into 20 by sum of them is 25. Okay, so you can have a look there. This is 300 minus 200, 100 divided by 25 is 4. Okay, so this is coming out to be positive. Okay, so that means it is along this force, this term is dominant than this terms. That means it is compression in this case. So what is compression? So total X naught, total compression is 2F effective divided by 100. Okay, that is 0.08 meter, that is 8 centimeter. So I think many of you have got the right answer. This is. After this we need to find out, okay, what kind of, okay, so this kind of question you know how to solve quickly. Okay, force is applied in any direction, and you have to find out what is total compression or elongation in the spring. This is the way to find out. Here 8 centimeter is total, okay, in this case compression. Why? Because this term is more than this, and this force is along the spring, so it is a case of compression. How to find out individual? So for this I have given one formula, which I am going to repeat it again. Yeah. Dipesh Patel, your answer is right. Okay. So, okay, let me tell you how to find out individual compression or extension. So, I will generalize it. Say initially these two masses M1 and M2 is at natural length L0, and then they have been extended. By total amount here x0. So, this was L0 up to here, it is L0, and say this has pulled it in this direction by x1 and this by x2. So, total extension x0 is given here as x1 plus x2, and here x0 we have got here in this case is 8 centimeter. So, this much. Okay. Let us try to find out here that what is the individual displacement. Okay. So, to find out individual displacement, I will try to show you the force in horizontal direction. This is kx naught, and this force is also kx naught. So, do not forget that the total force in the spring is given by k into total extension or compression. Here it is extension, so I am writing kx naught. These two forces are cancelling each other if I am taking M1, M2 as a system. Okay. So, there is no force in horizontal direction. So, in horizontal direction there is no force, there is no acceleration. So, center of mass remains at same point. So, total force is 0 in horizontal direction, and what is initial velocity? Nothing. It has been pulled by distance x1 and x2 and released. So, there is no initial velocity. So, VCM will be 0, m1 v1 is 0 plus m2 v2 is 0 upon m1 plus m2 is VCM. So, the velocity of center of mass is 0, so RCM does not change. If there is no velocity, the object will not leave its position. So, RCM remains same. You know that what is the formula for RCM? m1 r1 plus m2 r2 upon m1 plus m2. Apply this formula in horizontal direction. Initially, I am taking this as a reference point. Okay, this is fixed over here. So, I will just write here reference point from where I am going to measure the distances. So, initially RCM is m1 into 0 plus m2 into L0 upon m1 plus m2, this diagram. Okay. And here RCM will be equal to m1 minus x1 because it is in left hand side plus m2, okay, plus x2 because that is in right, L0 plus x2. I am sorry for this because distance must be measured from the reference point from here. So, L0 plus x2 upon m1 plus m2. Since VCM is 0, since force is 0, so ACM is 0, center of mass acceleration is 0. So, velocity of center of mass is also 0. So, RCM will not change. So, equate them. So, m2 L0 upon m1 plus m2 equal to minus m1 x1 plus m2 L0 plus m2 x2 upon m1 plus m2. Cancel out. So, m2 L0 equal to minus m1 x1 plus m2 L0 plus m2 x2. m2 L0 cancel out. So, m1 x1 equal to m2 x2. This is the final expression you should remember. So, whenever the question is given, total extension is given and you have to find out individual displacement, okay, this is the correlation you should memorize, m1 into displacement in this into m2 into displacement in this. So, this will always followed. Okay. A spring either in the will be in the compression state or elongation state, it does not matter. This is the correlation m1 x1 equal to m2 x2 and x0 is x1 plus x2. So, solving them you will get like this, x0 equal to x1 plus, in place of x2 from here is m1 x1 upon m2, x1 common 1 plus m1 by m2. I am taking LCM m2, m2 plus m1. So, here x1 will be equal to, I am writing here, x1 will be m2 upon m1 plus m2 into x naught. So once you wanted to know what is the individual displacement, compression or elongation, you should go like this. Again reverse m2. If you wanted to know what is the extension of mass m1, just in numerator you should take mass of m2 divided by sum of the mass into x naught. Okay. So here in that question I have given 8 centimeter was the extension. You can get the individual expression like this. Okay. I'm rubbing this. So x naught was 8 centimeter, and you can recall the diagram over here that I had given to you. I think it was 10 kg, 15 kg and 20 Newton forces were applied. Okay. It's a case of compression because 15 into 20 is 300, 10 into 20 is 200. Okay. So you have to find here k is 100, individual x 6 kg. So if you wanted to know what is individual displacement of 10 kg, okay, then it will be equal to 15 divided by 10 plus 15 into 8, okay, which is coming out to be, okay, 15 upon 25 into 8, 3, and this is 5, 4.8. So another will be 8 minus 4.8 will be 3.2. So you can, another way to find out 8 minus 4.8 is 3.2 centimeter. This is the way to find out the individual displacement. Is this clear? Should I give you one more question? Will you try to solve it mentally? Okay. Okay, question is this: 8 kg connected by 12 kg. This is pulled by 10 Newton, and this is pulled by 5 Newton. Okay. So is this clear? K, to keep it simple, I am again giving 100, and you know what is the question. So now I wanted to see how fast can you solve this kind of question without going into details, because I have already discussed the theory. So try to find it out. Okay, I am rubbing this. You have to also tell me compression or elongation. Okay, Dipesh Patel has one question. Is it possible to find extension or compression in spring at time t? Yes, it is possible. I will explain a little bit about this. Okay. Since your force is variable, so you have to go by integration method to calculate the, okay, extension or compression in a given time. Excuse me. Yeah, M. Aditya, you are right. So quick, very nice. I understand. Sanjeev Kashyap, sir, is this for us or 11th? It's for 11th class. Yeah, 8.5.6 and 8.4. So, if you know the trick how to solve, otherwise it becomes very difficult if you start thinking from the beginning, because this force are unbalanced, then spring will be extended, and then still it is very difficult to know whether the spring is extending or not. Okay, so how to find out first that whether the spring is extending or not? I told you, okay, how to solve it mentally. Have a look. So I'm telling it mentally. 8 into 10. 10 is away from the spring, not towards the spring, where 10 newton is away from the spring. 8 into 10 is 80. 80 minus, why 80 plus, 80 plus 12 plus 12 into 5. So that will be 60, 140. So it's quite easy to understand in this case that what is either it is extension or compression, because they are in opposite direction, away from the spring. I wanted to say, see here, this force is away from the spring, this force is away from the spring, so certainly it will extend. Okay, so you have to solve it mentally. Certainly extension will happen, and how much is this? 8 into 10, 80 plus 60, 140. 140 divided by 20. 7th taken. So 7 Newton effective force. You can check. Okay. So 7 Newton and then 2 effective, 2 into 7 divided by 100. 14 divided by 100 is 14 centimeter. And once you got 14 centimeter, okay, solving it in your mind, okay, then you can think what is extension in 8 kg. If you wanted to know what is extension in 8 kg, in numerator take 12 kg. 12 by 20 into 14. 12 by 20 into 14. Okay, 4 3 ja, 4 5 ja, 42 by 5, 8.4. So you can check, so many of students have answered it correctly, 8.4 centimeter, and rest you don't need to find by this method. Just 14 minus 8.2 will give you answer 5.6 centimeter. So this is the way to solve the question mentally. This question, now 5 Newton is in opposite direction. Okay, now decide, okay, what is the answer, and then we'll go for next kind of question. Today we'll cover it, all the question related to relative velocity on a person moving on a plank, or two mass is attached with this spring. What is the how much spring should be compressed so that another mass is jumping off from the ground? All this question we are going to discuss after that. Okay, so this is the last question based on this. Okay. 1 centimeter total. Okay, and so what is individual? Is it extension, Jay? Two centimeter, okay. M. Aditya has answered. Jai, just check 2 effective by K, force effective. Find out force effective first, and you know that one force is away from the spring and one force is towards the spring. So you have to first decide whether it is a case of extension or compression. Okay. I wanted everyone to decide this point, whether it is compression or extension. So here in this kind of question, okay, how to decide whether it is compression or extension? You think like this: 10 Newton away from the spring, so 8 into 12 minus 5 into 12 divided by 8 plus 12. You can have a look that this is 80. 8 into 10, 80 is more than 5 into 12, 60. And this force is away from the spring, so it will extend it. So this is case of extension. So it is extending more than this is compression. Extension is more than compression over here. That's why finally it is okay extension. And what is the value of this? 80 minus 60, 20, 20 by 20. So this is 1. I'm sorry for this. This must be written as F effective. So this is 1 Newton, and then you have to write here x naught as 2 into F effective divided by 100. So it is 2 centimeter. Okay. So this is 2 centimeter. And once you know 2 centimeter, then you can say like this: extension x 8 kg will be given by 12 upon 20 into 2. Okay. 4 3 ja, 4 5 ja, 0.6 into 2, 1.2. So another will be 0.8. Match your answer. This is a case of extension. Yeah, correct. Mehul is right and M. Aditya right. Dipesh, you are right. It will be extension. Yeah. So have a look. So all right, there is no confusion in this kind of question. And Dipesh wanted to know that how to find out, okay, what is extension at any time t. I'm not telling for 2 mass spring system. I'm telling by 1 spring mass system at any time t what is the extension. I'm giving a theory a little bit. Okay, so keep all this concept ready in your notes. Okay, whenever required, you can just revise before appearing for any examination. Okay, it will help you to solve question very fast. And if you don't look at the notes, okay, or if you are not revising, then you will forget the concept also in this case. That's why you must practicing some question based on that. Now next one is what is time taken, like Dipesh has asked. I'm making a very simple system, K and M, and force F is applied. At any time t, what is extension? He wanted to know. Is it possible to find out extension at any time t? So here I am writing xt. So think how to solve this question. Okay. So you can have a look. What is extension and compression at any time t? At t equal to 0, force start. Force is applied. So what is t equal to 0? At t equal to 0, force is applied. That means the object will start moving. So first you make a concept for a one mass, and then you can convert for the double mass system. Okay, try. Yeah, so you are right. If F effective comes negative, then it will be the case of compression. Okay, so I have explained in details that how to decide whether it is compression or extension. Okay, you can take any data by yourself. Okay, like I'm just at random. Even I'm don't know what will happen in this case. At random, I'm writing here. compression or extension, and you have to do it mentally. So since they are in the same direction, so confusion is there. If they are in opposite direction, no need to think. Okay, like if 15 Newton is in your left hand side, so certainly it will be extension. But in this case, how to decide? 5 into 20. So away from the force is, or effective is 100 minus 10 into 150. Okay, divided by 15. Is it coming out to be negative? So that means 15 Newton into 10, 150 is more than 5 into 20, 100, and this 15 Newton is towards the spring, so it is a case of compression. So here compression is happening more than the extension here. Okay, so it's very easy to decide like that. Clear? So now we'll come back to this question. How to find out extension at any time t? Say at any time t it has extension of x. So here force will be kx. So now the equation will be like this. Total force F minus kx equal to m into a. Okay, F minus kx, where F is remaining constant. So force is always applied constant, and I told you that if force is applied constant, extension always happen 2F by k in this case. Do you remember that? X is given by 2F by k. Simple case 1 in this case. So 2F by k. Why? Because at F by k the forces will be equal. I am just giving a quick revision, like I have discussed that question before also, that if force F is applied, what is the extension in the spring? So extension in the spring is not F by k. There it's a mean position where forces will be equal and opposite. Okay, but at that time it will gain the velocity, so it will go further and it will stop some distance ahead, and it is given by 2F by k. So it's very, very important point. So, okay, so we know that what is where it is going to stop. Okay, so here if it is going to, I am going to write the equation F minus kx equal to ma. It can further written like this, m into dv by dt, but now there are three variables v, t and x here. So you can apply chain rule. Okay, this is v. So this becomes F minus kx dx integration equal to m v dv, and when velocity was 0, or when extension was 0, that time velocity was 0, it was not given any velocity. So at any time v, this will be here, say extension is x. So you know how to solve this part first. Okay, so once you apply this, solve this part, you will calculate what is the value of v in this case. Okay, and then after v, whatever the value we are getting here as v, what will do further? In this case, again integrate v as dx by dt to get the answer. So solving this, you know what is the answer you are going to get here. Okay, so this is the way to find out what is. If you want, I can show you some more step. Okay, like m into v square by 2 equal to, okay, this is f dx kx dx. So coming out to be fx minus half kx square equal to mv square by 2. Okay. So have a look. This expression is familiar to you. If you think carefully, you know this expression how to write without integration. Anyone? Is this equation familiar to you? Can you write this step directly? So what I am explaining, is it clear to you? I am explaining what is extension at any time t. But here I am going to get, okay, what is, when extension is x, what is the velocity v? Soon I am going to tell you how to solve it further. But first you try to identify this equation. Is it known to you, this equation? Can you come to this equation directly? Type it over here. Let me see how many of you can think of it. Yeah, Jay, very nice. Correct. Have a look. Jay answered it correctly, that it's not a work energy theorem. So let's try. Work energy theorem tells you that change in kinetic energy, say after, when the extension is x, at that time this is half mv square. change in kinetic energy, half mv square, say its velocity here is v at any instant when its distance is x, that is equal to work done by all the forces. So F and x are in the same direction, इसके लिए Fx, and you know that spring force is in left hand side and this is in right hand side, and you know that spring force is variable, so work done coming out to be half kx square. So this is minus half kx square. So you could have avoided this step. Okay, you could have written that, but I didn't tell you initially because I wanted to make it clear that next time if you are getting this kind of question, you can directly write v and x. So now I am going to tell you one more method how to solve it mentally also. Don't worry. Okay, but you need a little bit concept of SHM. Then you can solve it mentally. But anyhow, let me tell you the what is the method to solve it first, rather than solving it mentally. Okay, so this is the method you come to know, and then you can further solve it by taking. You can calculate this value of v, and then you can write v as dx by dt, and you can solve it further. So next step will go like this: multiplying both side by 2. And writing v as and then writing this as dx by dt. I am just writing here dx by dt. Okay, and then you can variable separable method. So next value will be dx under this terms root 2fx minus kx square, okay, equal to 1 by root m dt. So at any time t at t equal to 0, initial extension was 0. So at any time t, extension is x. You need to solve this equation. Okay, and you know how to solve this integration? By completing the square. You will complete the square. It will come in the form of x square plus x square variable. So it will be in form of tan inverse. Okay, so this is the way. So you can see that this is going little bit complicated. It's not that you cannot solve this. First you have to make it completing the square. You have to convert into a square term plus some constant. Okay, and then you can substitute the value to know the answer in this case. Okay, so this integration, if you want, you can try by your own. I give you the hint. First you complete the square, make it, you have done this kind of question in class 10th, that how to complete the square, say x square minus 10x. Okay, you are just to make it real, completing like this, 2f, f is constant. So I'll just write this as say 10x minus 5x square. So you know how to complete this x square. This is this form, and then substitute the value to know what is the time t. At any time t, what is the extension x, correct? So now this motion will be periodic in nature. I think Bhaskar sir has already explained to you. Let me tell you that without integrating this, okay, how to solve it mentally, what is the extension at any time t, correct? So how will you get that? How to solve? X equal to a sin omega t first. Okay, so you know that, so you have to find out how much time does it take to reach from mean position to extreme position, which you know by t by 4. Okay, so if you wanted to solve it further, so this is the way to solve even for this simple question. So just think about, if two masses are there and a spring is there, okay, one kind of concept is required, okay, which is called effective mass system, to calculate what is time t. But itself, to find the time t here, you need to integrate this. Okay, so you can integrate this later. Okay, I'm not going to spend time over here because you know that it is going to be lengthy. There must be some trick to solve it. Okay, so what I'm going to do, that I'm going to tell you how to find the time t by SHM method if you want, or you try it by your own. Next time I can explain, but I can give you the hint. Think, if force F is applied, it will reach to in mean position. Okay, so what will happen? It will, once it is pulled by force F, okay, it will reach to some extension, 2f by k. Okay, so what is amplitude? So here mean position is at f by k and maximum extension is 2f by k. So here amplitude becomes f by k. Okay, all right. So I'm just rubbing this and again explaining. Have a look. What I'm saying again I can repeat. Once you apply this force F, say this is a position where forces will be opposite, say kx naught. Here extension is, this is x naught. So left hand side force will be this kx will become kx naught equal to F. So x naught is F by k. Here motion will not stop. I have explained this very well last time. What will happen here, it will gain some velocity, so it will stop further here, and by applying work energy theorem we come to know that this total x from here, x maximum, is given by 2f by k. So what is amplitude from mean position to, so amplitude definition is quite clear to you, right? I hope so, that amplitude is our maximum extension from the mean position. So this is the mean position and this is the extension here. So this is 2f by k minus f by k is amplitude. So A is given by 2f by k minus f by k is f by k. So let's see what will happen. Once you apply the force, here velocity is 0. Here again velocity will become 0. I am saying here v is 0 initially when the force was applied, and it will be 0 here, and again it will be 0 here, and so on. So it will keeps on moving between this. So I told you how to solve it mentally. I told you that to solve the equation you need to complete the square, and it's going to be very, very difficult to solve. I mean lengthy, I should not say difficult, it will be lengthy to solve it. But there is some shortcut method available by which you can find out what is time taken t. But I have to take the help of simple harmonic motion, otherwise it is not possible to solve it mentally. Have a look how. F by k, and here it is at maximum compression. You can visualize like this. You are pulling it here, velocity v, and then here becomes mean position, extreme position, mean position, and extreme position. It will keeps on moving. Okay. So let me tell you what is happening over here, that once you are pulling here, once you are reaching over here, F, and but this side the force will be k into, okay, x naught, 2x naught. Check it. Because at mean position f equal to kx naught, and extension is double of this. So you can check here what is the value of this, 2k into 2x naught. So now this force will be dominant, okay, left hand side, so it will pull it back. So it will pull it back. Are you getting why it will pull it back? So don't think like this, it is v velocity here and then it will stop forever. It will not stop forever here. Here the force still is f, and what is here extension in this case? Let's try to find out. K into, you can check here extension, this is given by f by k. Okay, so this is already x naught and this is x naught again. So you can say 2x naught. Have a look, x max is 2 times f by k. What is f by k here? X naught, 2x naught. So here over value will be 2x naught, and kx naught will balancing the force. So that's why 2x naught is more than f. So this will pull it back, but once it reaches to the mean position, again it will gain some velocity and it will being compressed here, reach to natural length in this case, and again come back. But the thing is that here this is the mean position. Okay, so it's similar to a question which is, I'll just explain it. This one, just analogical problem. Have a look. Mk, mg is throughout downward. So it's same question like this, and then we'll compare with this to understand the subsequent motion of this. Okay, have a look how. If you're taking here k and this has m and you are releasing it, okay, what will happen once you release it in this case? It will under the influence of mg force always, whether it is coming down or going up, same like here f. F is always horizontal, and this is mg. I am telling you how this question is matching with each other, because you are very comfortable about the time period of this t equal to 2 pi under root m by k. So let me explain this first, how is the motion of this. So say here it is at natural length. So at natural length, if you are going to release it v equal to 0, it will go to say mean position where velocity will be maximum, and then it will stop here further by the same distance, okay, x naught plus x naught, 2x naught, and then here this force k into 2x naught is more than mg. So this force will pull it back. So once it will reach to mean position, again it will be v maximum, and once it will reach here, it will velocity will become 0, Now compare that, what I am saying. Did I explain well here this point? It will reach to its mean position, extreme position, mean position, and left extreme position. Again velocity will become 0, similarly to this. So can you tell me what is the time taken, okay, from here to here to here to here? How much time does it take? So you can see that it is here, equation will be A sin omega t or A cos omega t, where omega is under root k by m. Who will tell me which one is right, sin omega t or cos omega t? Don't be in hurry. Out of these two, one is correct. Which one is correct equation to find out, okay, a equation? This case or this case doesn't matter, they are same. So you can explain by this one. Okay, so I'm checking who is answering this question. Dipesh Patel, you try to think. You have asked that question and I am explaining it without involving integration. Okay. Yeah, Jay Goyal, you are right. Cos, why? Because once you are taking t equal to 0, at that time extension is a or minus a. Am I right? So here equation will be, in this case will be cos. If you are going to take sin 1, then t equal to 0 will make it x equal to 0. That means the object is at the mean position, which is wrong. Object is not at the mean position. Object is at the extreme position. So you can take this equation. Okay, and then you can find out, okay, how much time does it take to come down. So from here to here, here to here, you know that this is t by 4, this is t by 4, again t by 4 and t by 4. Total time is t and t is given by t equal to 2 pi under root m by k. So this is the way to find out time t, okay, for any position. So have a look. So finally, what will you do? If you wanted to know what is the time taken, okay, to reach to distance x, not the extreme position, then you have to write here x cos omega t as x by a, then omega t equal to cos inverse x by a. So t will be 1 by omega, omega is root k by m, so this becomes root m by k. Okay, omega is root k by m, so this is m by k into cos inverse x by a, and here x will be given to you, so this will give you time t. And if you wanted to, if the extension is given here over here, okay, this is the way to find out time t. If time is given, this is the way to find out extension. Clear now how to solve it mentally, this kind of question? So once you learn about simple harmonic motion, you should know also how to apply and where to apply. You have seen that while solving this question by force diagram, by force method, first you need to integrate and again do the double integration. Not I am saying double integration, again integrate to get the value of x in this case. But you know this is similar to analogical question is this, and this kind of question is already explained in the class. So final answer will be this. Is it clear now? Okay. So you can think if two masses are connected with each other, then how much time does it take, okay, or at what time what is the compression, and if compressor or expansion is given, how much time does it take. Okay, you can solve it by, okay, double oscillator system. Okay. So you check your notes, sir has explained to you double oscillator system where one mass, do you know double oscillator system? Can you type it over here quickly? Okay, so is this clear now how to find out time t mentally for this kind of question? At least one mass and one spring system. And again I can explain for two masses and spring system. Again that question can be solved mentally. Okay. I wanted a response from Dipesh Patel. Did you understand it? Okay, Dipesh, I was waiting for your response. All right, and then again you type it over there. Double oscillator system has been explained to you or not. I'm talking about this case where two masses are connected and they are oscillating like this. Say this by x1 and this by x2 extended. Think in this way. Say this is natural length L0 and capital M has been extended to x1 in left hand side and the small m is extended to right hand side by the x2 and then release. So total extension is x1 plus x2. So both will perform SHM. Its amplitude of m will be x1, it will go up to x1 this side and this will x2. So it has individual amplitude will be x1 and this will be x2. Okay. So in this case, okay, what is the equation x and t relation? Then you can solve. So I think, sir, this is called double oscillator system. So can you solve this question? Has it been discussed with you, this one, double oscillator system? Let me know. It's not very difficult. I can tell you in just 2 and 3 steps how to solve it. But if it has been already discussed in the class, we will go for the next kind of question. You are talking about this formula, Jay? M. Aditya, I think. Aditya has asked. Is final equation formula or only to understand? Neeraj. It's if two masses has been pulled by distance x1 and x2, what is their time period t? This is the question, time period. Okay. So if single mass and single spring system is like this, everyone know that t is given by 2 pi under root m by k. But if two masses are oscillating, what is time period t in this case? Okay. So what's your opinion here? How to solve this kind of question? Okay. I think it has been explained to you. Okay. I think it has been explained to you. So should I give you the direct answer or should I explain it? Here t will be 2 pi m effective by k, where m effective is given by multiplication of mass upon sum of mass. Check your notes. Has it been explained to you? This is the answer for this. If two masses are connected, then time period is given by 2 pi, same form m by k, but m effective is multiplication of mass upon sum of their mass. So this is the way to find out time period t. Has it been explained to you? I mean, to how to solve this equation or no? Let me know. Okay. Rohit, Jay, Aditya Nambiar, those who are responding, let me know. Has it been explained? Iraf, okay. So it has not been taught, but you can understand it very easily because, okay, required theory I have just now explained to you. Okay. So let's see. Here total extension is x naught is x1 plus x2, and this extension is x1, so mx1 equal to mx2. Okay, is this clear to you? This equation just now explained that if two masses are connected, then what is the correlation between them, because their center of mass will not change. So by solving that, center of mass remain at the same position, because anyhow this force F and this force in the spring at any instant is say kx, where x is the extension. Then this is natural length, I should not show you here, somewhere by extending it by here, okay, mass, you can say now the masses are like this, m, and this is small m, this is x2, this is x1. Okay. So it has been extended, now we have shown you clearly here. So here x naught is x1 plus x2, and once you extend it here, the force here will be k into x1 plus x2, and here the force will be k into x1 plus x2, where x1 plus x2 is x naught. Is this clear? So say that this mass at any instant it is in left hand side by x1 and this is in right hand side by x2. They have been elongated and released. They will perform SHM. So this is the force at that instant. So this is restoring force. So once you displace it by distance x1, what is the restoring force for m? Okay, try to find out what is restoring force. K into x1 plus x2. Don't write k into x1, it will be wrong. Though its individual displacement is x1, still the spring force is k into x1 plus x2. So net resultant force will be in the direction of displacement. So you can see that displacement is in left hand side. This is x1 is left hand side and the spring force is in right hand side. So net effective force is opposite to displacement. That's why I am writing here minus sign. It has been explained to you, right? That restoring force is always of minus sign because displacement is in left hand side. Because of this, there is a force appearing which is k into x1 plus x2. Okay, force equal to m1, capital M into, okay, you know that how sir has explained to you this question, single spring system, how to find out time period of it. To find the time period of this, you need to extend it by distance x, say like this. Okay, so it has been extended by distance x. Okay, and then here the force will be kx and displacement is to your right hand side. I am coming back to this, don't worry, just first this one. So this is the force in left hand side is kx and displacement is in right hand side. So net resultant force is minus kx. Why to write minus kx? Because displacement is right hand side and force is opposite to that. So this is minus in this case. So negative of displacement. And this is equal to m into a, and for any object which is performing SHM, a is given by minus omega square x. And then here minus minus cancel, x cancel. So omega square equal to k by m. So omega is under root k by m. I think everyone knows how to solve this equation. So just recall it here, how to solve. Now you can compare. Again I am writing here m into a, and a is minus omega square into x1. Why x1? Because the extension is here. So here I have written omega square x, where x is, okay, x is called extension or compression from, okay, its mean position. So have a look here, I am pulling it by distance x, so it's a elongation in this case. And but for capital M, actually force is k into x1 plus x2, but its amplitude is how much? x1. So here you can say not amplitude, you can say that extension is how much? x1. So this x stand for omega square x, this x stand for extension or compression from natural length for the spring case. So here I am writing x1. Is this clear to you? Okay. Similarly, if you wanted to write the equation for this, okay, small m, you have to write like this. Here displacement x2 is in right hand side, check, but force is in left hand side. So again minus, equal to a small m into, okay, minus omega square x2. So both equation is right, you can check. Correct? Now you can write like this, minus k x1 plus x2. If you want, minus cancel out here, and then k x1 plus x2 equal to capital M omega square, and this is x1. Okay. What is x1 plus x2 correlation? mx1 equal to mx2, this relation. Substitute the value x2 here, it becomes k x1, and x2 value from here is mx1 by m equal to m omega square x1. Here x1 is common. X1 cancel out. Take here k, LCM m plus m equal to m omega square. So omega here will be, omega square here will be k m plus m upon mm. So omega will be under root of this. So t is 2 pi, just reverse of this. So this will go here, k will down, and this m plus m will be down by k. You can have a look. So we have proved it. Similarly, you can solve this question like this here. Cancel out k x1 plus x2. x2 from there is mx1 by m equal to m omega square x2. Oh, here I should write x2 so that x2 is cancelled out. So just x1 will be given from there is mx2 upon m plus x2. Here x2 is common over here, m by m plus 1. x2 cancel out. I will take LCM. And then omega square will be k m plus m into mm. Okay. And then omega will be under root of this. So t is 2 pi and inverse of this. So this will mm upon m plus m divided by k. So you can see I have gone by both method. I have written the equation for both, but I am getting the same answer t here. So this is time period. So if two masses are being pulled and all this thing, and they wanted to know how much time does it take, what is extension, use this t value. Okay, use the equation, but effective mass you have to take mm upon m plus m. Okay, is this clear? I hope it is clear to you everyone, this theory. What is double oscillator system? It's same like single mass system. Okay, so here you can, if this kind of question they are asking here, what is, okay, let me tell you that if two masses have been connected, say M1 and M2, and total extension given is here x naught. They will not give you x1 and x2, x naught. What is their time period? So you can think like this: time period is 2 pi m by k for single mass system. Here this is m effective. Now what is m effective? It's like this. You can visualize like this, that if m1 you are going to stop it, fixed it, then only m2 is left. And but in fact both are oscillating, but you can change into double oscillator system, can be changed into a single oscillator system. But you have to change one important thing, that the mass of this should not be taken as m2. So if you are thinking, if you wanted to convert into single oscillator system, for this you have to freeze the mass m1, you have to fix the mass f1, and then m2 will move in this case. So what will happen, that if this is oscillating, its mass cannot be taken m2, it must be taken m1 m2 upon m1 plus m2. Okay, if you wanted to fix m2, then the mass m1 should be taken again, multiplication of mass upon sum of the mass, to get the time period in this case. So it is clear to you how to solve this kind of question. Okay, and individual displacement you know. And if they wanted to know what is amplitude here, say it has given that it has been compressed or elongated by a distance x naught. So this is x naught is elongation. Okay, so once it is elongated, okay, or extended, what is its individual amplitude m1? So x1 is given by, so if you wanted to know x1, it is given by reverse mass m2 upon m1 plus m2 into x naught. Just now I have explained this part. So this is the amplitude of each. So they will oscillate with the same time period t, but their amplitude will be different here. So this is called double oscillator system. So it's relevant, that's why I discussed that. Otherwise you'll think that why I'm teaching you SHM question now. Okay, but you know what to, okay, this is related to spring mass system, so I told you in this case. So you can find out what is extension, compression, all this thing, and how much time does it take to oscillate, okay, easily by this way. Okay, so next, if you have any difficulties, let me know. You can type your doubts over here. No doubt. Any question? I'm waiting for your response. Do you have any difficulties, anything here? Okay, so say this is mass m1 connected to mass m2 by spring constant K. Okay. So look at this diagram. Once m2 is on the ground, this is spring, vertical spring, and m1 is kept. So spring is naturally come down by some distance. You have to find out, and then it is compressed by some distance. Okay. Okay. So what is the value of x here, or x naught? Further compression from the mean position, such that m2. So what is x naught for which mass m2 will leave contact with the ground. So once you compress it and then release, this mass will go up and further up, and maybe it will pull it m2 up. So what is the minimum value of x naught? Okay, you cannot compress it to any distance, minimum value. So if you want x naught is, I am writing here, what is the value of minimum compression? What is minimum compression x naught for which mass m2 will leave the contact with the ground? So can you solve this question? So now we are discussing a kind of question where, okay, the object, another mass is leaving the contact. Okay, and this kind of question is quite important for JEE advanced exam. Okay, concept I am talking about, not this question. Okay, so try to find it out, try to solve it by yourself first, and then later I will explain the theory. Okay, question is, okay, so what is question? What is the value of x naught? See, if you're taking a spring and keeping a mass over here, and these two springs, this is connected to a spring attached with the masses. So you don't need to ask question whether the spring is compressed or not. You can think by your own that once you are keeping a mass over here, okay, initially, okay, so it has not been released, it has been kept here. So it is at equilibrium. That means already spring has come down. Say this is natural length of the spring, natural length L naught. This is natural length of the spring, say L naught, and this is L. This now this is compressed by distance, say initially L. So clearly the force, it has come down from here to here. So force will be in upward direction because in spring is compressed down. So it will exert a force in upward direction, which is given by KL, and it is okay. So initially the spring is compressed by distance m1g by k. So, am I clear now? So now question is, how much further will you compress it? So once you leave it here, how much further you will compress it, okay, or minimum distance, how much minimum compression is required when you are going to leave mass m1, it will pull the mass m2 off of the ground. Okay, so you have to find out minimum compression in the spring for which this m2 jumps off from the ground or leave the contact with the ground. So is this clear now? So initially spring is compressed by this much amount. Keep on solving, try to solve it. Okay, I will explain soon. Okay, I got answer from Ayusha. 2m1 plus m2k. Okay. No, here mass m1 is not left from height. Check it again, Ayusha. Is it 2m1 plus m2 or 2 brackets start m1 plus m2 by k? G will also come in this case. No? Okay, G is there. Okay, correct. Try again, Aditya. It's not right. See, this kind of question is conceptual, not lengthy. Okay, there they are asking a very simple question that once it's being compressed further by x naught, when this mass m2 will leave the contact. So when it will leave the contact, first you need to understand the concept that when the normal reaction is equal to here. So say this force is spring force. Okay, just I'll write F. As soon as this F is spring force is equal to m2g, it will be lift off. Okay, it will leave the contact. But what is the force in the spring such that, okay, so if m2 is normal reaction is 0 for this, F spring is must be equal to m2g. It's something like this here. Say this is a box of 5 kg. What is the force required here such that it leave the contact with the ground? So once you are not applying a force, it's a normal reaction of 50 Newton. Okay. Once you are applying a force here F such that it leaves the contact, that means N becomes 0. And when N equal becomes 0 here, when F is equal to 50 Newton. So you can compare what I was saying with this. Okay. So at the time when force is equal to 50 Newton, say the force applied here is 30 Newton. When still normal reaction is there, you can have a look how F plus 30 equal to 50, F equal to 20 Newton, N plus 30. So normal reaction is 20 Newton. It's very easy to get the normal reaction. Say now you have made it 40. So at 40 this will become 50 minus 40, 10 Newton. So as soon as you make it 50 Newton, okay, N will be 0. So remember directly that once you are applying a force equal to its mg, okay, it will leave the contact. So is this clear to you now? F spring is m2g. But what is F spring? And here force, direction of force in the spring should be upward. Okay. So when you are compressing the spring further by say distance x naught, then say spring comes over here, then what is the force at that instant and what is the direction here? Have a look. So here the force will be how much? So you have to understand each and every point very clear that what is direction of force given by the spring. So once you are further compressing like this, what is force and direction on M2? It will increase normal reaction. Let me tell you how. So in this case, total force in the spring will be K into extension from compression from natural length. Already L distance is there and further x. So KL x naught. This is the total force where L is m1g by K. Okay. So this is when you are compressing it by distance x naught, okay, then it is further compressed, spring will be further compressed, say it's compressed like this. So natural length of the spring was here to here and it is further compressed, say it was here, say something like this. Then here is the force and here is the force. So you can visualize like this, you are taking a spring and keeping one end fixed and another is you are pushing it down and release, both end will move up. Okay, one will go down, another will above. Again, take a spring, okay, even you are keeping this constant at same distance and you are pushing further down and release. So this end will go down and this end will go up. So here I have shown you movement of them. So here it will move like this. So once it is further compressed, spring is compressed like this. So once you are going to release, so it will spring will expand like this here. So this will be force. So in the when it is compressed, direction of force in downward direction will be there. Okay, and it will increase the normal reaction. So once it is further compressed, okay, by distance x naught, direction of force in the spring will be in downward direction, not like this. Okay. So when it is going to lift the mass, when the direction of the spring will be upward direction, and when it will be in upward direction, think. So who will tell me that this spring force will be in upward direction? When it is being compressed, at that time it is in downward direction, and it is given by this one, K, this much force, m1g by K plus x naught, K cancel out. Have a look. So this is the force in downward direction. So on M2, now the force will look like this. Spring force M1g Kx naught, normal reaction N, and M2g. So your normal reaction will be N is upward and these two are downward, so add them up. So this is normal reaction, it has increased. Okay, so I'm telling you, I'm discussing each and everything so that your concept becomes clear about the spring and mass system clearly. And later I will tell you that this kind of question also can be solved mentally, but you need to know some tricks to solve that. But here you have to understand first that spring, okay, initially when it is compressed, it will further push the mass M2, and this much will be the normal reaction. Though I have not asked what is normal reaction, but you should know each and everything in this question. Have a look. Okay, now further. So once it is compressed by x naught and released, the spring will go up. At what height it will start exerting the force, okay, in the spring in upward direction. Once the force will be in upward direction, then M2g will be lift off. So who will answer this question? From which height or where this force will be in upward direction? Okay, what is the location of this mass where it will exert the force in upward direction? Okay, so type it over here. Let me see how many of you know when the force will be in upward direction. Okay, quick. Your rough no, answer is not right. Okay, you answer this question. Okay, at what position M1 will reach for which the spring force will be in upward direction? Okay, so you can compare with the position like this: mean position, natural length, below natural length, above natural length, above mean position, below mean position. You can type like that, whatever you feel. Okay, so Aditya has given a response when there is extension, and when is the extension? From what position the extension start? L naught. Okay. Anyone else? So I have got two response till now. When new length is more than natural length. Yeah, Aditya, you are right. So this concept, okay, if it is clear, then you can solve this question after natural length. Good one. Okay, so I must start getting response that once this mass will reach above this position, say somewhere here, look at the diagram, everyone. So this mass is here. After that, once it pushed it by distance x naught, it will reach to mean position. Here it will not reverse the direction of spring because still it is below natural length. I'll explain. Look at the board, everyone, what I'm saying. So this is M1 here, and then it is pushed further by distance x naught. Then you know that direction of F spring is downward, and then it will go up. When it reaches to its mean position, still the force is downward. Why? Because it is again, it is here is the natural length and still it is below the natural length. So when it's not like that when it start going up, because many times I have asked this question and students say that when the mass start going up, that time it will change the direction of spring, force in the spring, which is wrong. Right concept is that once it is below the natural length, still the spring is compressed, and if a spring is compressed, this F spring is downward. So when it will be in upward direction, when it will reach above the natural length. So see, I have shown you here. So on the natural length, there is no extension or compression in the spring, so force will be 0 in the spring. But once it will go up from the natural length, it will, the spring is, so you try to think in this way, you take a spring and try to extend it from the natural length and release, and you can see that both ends will go up like this here. So this will change the direction. So as soon as it is going up from the natural length, okay, the direction in the spring, okay, along the spring will be in upward direction. Have a look. So now this point is clear to you that once it is reaching up to some point, it will, okay, pull it off in this case, and say how much distance it will go up from the natural length. So now the question is that after making this concept clear that it will lift it off, if this is spring, this will go up of the natural length, but how much length? Okay, so say this is, I have taken L, so I will take this as L1. Say from natural length it has gone L1 up. So once it has gone L1 up, okay, then it will lift the mass, say assumption. So I am saying that after reaching to length L1, it will, okay, what will happen in this case? It will lift off in this case. So here I am going to write the equation. So once it is above the natural length L1, okay, here force, this side will be K L1 and this side F spring will be K L1, right? So once you pull the spring like this and release, both end will come down, this will be the end, both end will experience the same amount of force but in opposite direction, K L1, and this will be K L1. And if this K L1 is equal to, okay, M2G, when the F spring is equal to M2G, normal action will become 0. So by looking at this diagram, you can say that KL1 equal to M2G. Now let's try to find out L1. You can find the L1 value by applying, okay, work energy theorem or conservation of energy. Because spring force is conservative force, mg force is also conservative force, you can apply conservation of energy or work energy theorem. Okay, so first we will apply here work energy theorem. Here velocity is 0. Okay, so once it is reaching length L1, it stop, okay, and at that instant this is being pulled off, because this I am asking minimum distance. So when you are compressing a minimum distance, it will go up by some distance up, okay, and here exactly the velocity will become 0, and here was velocity is also 0. So when you are compressing it further by x0 and releasing at that instant, the velocity is 0, and when it is reaching here, velocity is again 0. So apply work energy theorem. Change in kinetic energy, 0 minus 0. So remember which two position I am taking. This position where it is compressed further, because I know that velocity is 0 over there, and once it is reaching L1 distance, okay, where the force is equal to M2G. So 0 minus 0 equal to work done by all the forces. So let's try first what is the work done by mg. Quite simple, look at the diagram and tell me. M2 is not moving, so no need to take that. M1 is only moving from this point to this point. Check what is this distance. So what is work done by M1? G, M1G is downward and displacement is upward. So minus M1G into distance. Okay, minus M1G, why? Because work done F dot S, force M1G is always downward while this mass has gone from here to here. So what is this distance? You can think in this way, x0 plus L plus L1, x0 plus L plus L1, check. So once it will reach to x0 distance, it will reach to mean position, further it will go to L position up, then it will reach to natural length, and further L1 will the position where this mass will be lift off. Okay, so this is the work done, plus work done by the spring. What is work done by the spring? check. Okay, so someone is saying till kx becomes equal to m1g. Yeah, kx1, kx not equal to mg. Okay. Is this clear? Now what is work done by the spring? I know many of you are also feeling difficulty to find out, okay, work done by the spring, is it plus or minus? So let's see, I will make this concept very clear to you, how to find work done by the spring. The magnitude of work done by the spring is half kx square, but sign is very important, plus or minus. Half kx square where x stand for, okay, compression or extension from natural length. Plus or minus, you think carefully here. If a work done, so direction is important. So when it is compressed up to x naught and released, okay, so here it is compression, okay, so spring force is where? In, you can have a look, once it is compressed over here, m1, what is the force on the spring here? Upward, okay, so m1 experience a force in upward direction. Okay, so try to compress this mass m1 further by x naught and release, this mass will go up. So what is the direction of force given by the spring? Upward. In another word, since it is compressed in downward direction, so force will be in opposite direction, F equal to minus kx. So what is displacement here? Downward. X naught is downward, so force on this m1 will be in upward. So this will be upward direction. So here till up to this point, okay, force is in upward direction and displacement is also in upward direction. So up to here, natural length, this point to this point, okay, I am just keeping my hand over here, have a look, up to this point to this point, okay, the work done by the spring is positive. Check why. Because force is upward and displacement is also upward. So this will be plus half k, okay, extension from natural length. Of course, this is going to natural length up to here. So what is extension? X naught plus L. So this is work done, plus I have used, minus, now why minus? Because it's going from here to here. It's changed the directions. Once it is going from natural length to above, the force on the spring becomes downward, m1, downward here, you can have a look. But still the displacement is upward. So after natural length, the force on m1 will be in downward direction and displacement is in upward direction. That's why I'm just breaking this, okay, work done into two parts, up to natural length and after natural length. Why? Because it changed the direction in this case. So this is very important concept, you should mind it, half into k into L1 the whole square, where L1 is extension from natural length. So here plus or minus. Many times I have seen the student, they write like this, half into k plus x naught plus L plus L1 the whole square, which is wrong. So you cannot take this term the whole square. Why it will be wrong? Because in between it is changing its direction. And where it is changing its direction? At natural length. So this is the way to write the expression. Clear? You come to know how to write work done by the spring? Okay, it must be very clear. Okay, below the natural length, okay, spring force and displacement is same, and above the natural length it is in opposite direction. So you have to write in two terms like this here. Okay. Now we will write these terms as minus m1g x naught plus L plus L1. We'll keep the value later. First let me complete this, plus half k common here. This becomes x naught plus L the whole square minus L1 the whole square. Okay, clear? I have taken a common over here. You can bring this term over here. So this side it will go and become positive m1g x naught. This is the question that I am asking x naught. L is known to us. So now start substituting the value m1g by k plus L1. Okay. So what is L1 in this case? m2g by k. Have a look. So I have written in this term here L1 and this L is here I have written. That is equal to half k a square minus b square, a plus b into a minus b Okay, have a look. In this case, if you look at this term, okay, this is being cancelled out. Actually, I should not have kept the value here. I am just keeping this as it is. Okay, and now see, x naught plus L plus L1 into x naught plus L minus L1. This term is cancelled out. Okay, so this becomes m1g equal to half k, okay, x naught plus L value is from there m1g by k minus L1 from there m2g by k. Now this 2 will come this side, and this becomes now, here I am going to write 2 m1g equal to k. So I have multiplied this here 2 m1g, and this becomes k x naught and becomes k cancel out. Okay, so m1g minus m2g. Okay, so k x naught will be, bring this term this side and this one this side. So 2 m1g minus m1g will be m1g, and this will come to this side, will become plus m2g. So here x naught will be m1 plus m2g by k. So this is the answer in this case. Check. So okay, so just have a look that what important concept you learned from this. I feel this one work done by the spring force. Okay, you can also solve this by conservation of energy. Okay, so there are lots of concepts involved here, that's why I have taken this question. You might be wondering that how this question could be solved, okay, mentally. I am going to explain soon. Okay. Now I will tell you how to solve this question by conservation of energy. You can apply conservation of energy because there are two kind of forces present over here, spring force and gravitational force. Both are conservative in nature, so you can apply conservation of energy. So for this conservation of energy, you don't need to see the direction or work done in this case. It's just the energy stored. So have a look. So once you are going to take this as a reference frame, what is a reference frame called? From where you are measuring the distance or displacement. Okay. So from this reference frame, I am going to measure height and everything extent. Okay. So let's try to write here. Okay, what is conservation? So I am applying conservation of energy, that is total energy initial equal to total energy final at these two positions. So initial, there is two kind of energy, potential and spring energy. Two kind of potential energy. Okay, potential energy stored in form of gravitational field, and another is here spring force. So what is potential energy? Because of gravity, mgh. So this is m1 g into h. H I am taking 0. Why? Because I am starting from here and here height is 0. Start because this is my reference frame or reference point from where I am measuring the height. So this is m1 into g into 0 plus half into k into x square. Now here, when you are writing a terms energy half k x square, Here x stand for, okay, extension or compression from natural length, okay, and here you don't need to see whether it is the sign is plus or minus, because you are not finding work done, you are saying how much energy stored in this spring. So what is the energy stored here? You can have a look, half into k into, and from natural length its length is L plus x naught. So this is L plus x naught the whole square, okay. So this is potential energy total plus kinetic energy 0, because velocity is 0 over here. So this is 3 terms you have to write, 2 potential energy terms, 1 kinetic energy, and that is equal to, when it reaches to the highest position where velocity becomes again 0. So this becomes m1 into g into height from the reference level. So what is height from the reference level? L0 plus L plus L1. Okay. Okay. Again plus, because it's the energy I am writing. So energy is always plus half kx square. So plus half into k into extension from the natural length L1 the whole square. So you can have a look which terms, and kinetic energy is 0 of course, naturally, because velocity is 0. So this terms m1g, and I am bringing this term here. So this becomes half k L0 plus x the whole square minus half k common here. So L1 square equal to m1g L0 plus L plus L1, and then you have to write half k L0 plus x plus L1 into L0 plus x minus L1 equal to m1g L0 plus L plus L1. This is cancelled out, and then you know how to solve this further, because I have already done this here, this step. So you can see that we are getting the same answer. So I told you by both method how to solve it, by conservation of energy and work energy theorem. In work energy theorem you have to take care of sign, okay. Work done by the spring is plus, either it could be plus or minus, but in conservation of energy there is no problem. You can always write plus half kx square, because a square is there, so it doesn't matter, okay, whether it is compressed or elongated. But in terms of work done, it matters in which direction displacement is there, opposite or in the same direction, okay. So is this clear now? Okay. Now how to solve this kind of question, complicated question, okay, mentally? By knowing certain things, okay. You have to take the help of SHM chapter again, okay. So I am going to explain how. Okay, who is? Okay, so there is one question, Aditya Nambiar. First he has asked, I got x naught Aditya, maybe you have made a mistake, okay, while writing the work done by the spring force. You check your notebook. Maybe you have taken the work done as both plus. And another question is, how can L not be considered if reference frame has not covered it completely? See, one thing you should know very clear, that what is energy stored in the spring, it is independent of frame of reference. It depends from what is extension or compression from natural length. So though reference frame is here, still I am writing energy here, half into k into extension from natural length. It is nothing to do with reference frame. Reference frame is only for calculate gravitational potential energy, whether it is up, down, or on the same level. If it is on the same level, it is 0. If it is up, then it is plus. Here you can have a look. If it is down, then it is minus. So you can know that why reference need to, when to use reference frame. Whenever you wanted to apply conservation of energy, okay, a reference frame must be taken. Okay, it depends on you where you are going to take the reference frame. You can take it anywhere, but I am taking here as a convenient point. Why? Because your velocity is 0, and then from here I will measure the height, initial point and final point. So reference point is meant to measure the potential energy due to the gravity. While if you wanted to calculate what is potential energy due to the spring force, it is always plus half kx square, but x here stand for natural compression or elongation from natural length. Okay, so keep this in your mind while solving this question. Okay, next part. Have a look. If you are, say this is a spring and here mass m is kept, okay, so this is natural length. From natural length, say this spring is initially it was here, it has come here, is L naught, okay, K. So K L naught, since it is compressed, so force is in upward direction, mg in downward direction. So once you keep the mass and attach it, a spring will naturally come down in order to balance its mg. K L naught equal to mg. This is quite clear to you. Now this is called mean position. Now I am to explain it mentally, so you should know some important concept, okay, so that you don't need to write equations, okay. How to solve this kind of question, okay, mentally. For this you need to know the difference between mean position and natural length. At mean position, forces are balanced. You can see net resultant force is 0, that is known as mean position. Once you compress this by some distance x naught and release x naught and release, what will happen? It will start performing SHM and its amplitude will be x naught. So say you are taking this mass m and compressing it by 10 centimeter down. So x naught I am saying 10 centimeters. So this will be from, if you release here, it will reach to mean position, okay, minus 10 to 0, 0 to plus 10, plus 10 to 0, 0 to minus 10. It will complete a cycle. So any object spring mass system, whether it is vertical position or horizontal position, time period is always 2 pi under root m by k, as you know that, okay. And here in this case you can understand one point, that, okay, the amplitude is always measured from the mean position. So once you are compressing it by 12 centimeter will become its amplitude. Why? Because once you are compressing it by 12 centimeter down from the mean position, that is known as amplitude. So certainly whatever you are compressing from the mean position, it becomes amplitude. So it will go further same distance up. So if you are compressing it by say 20 centimeter down, so no need to calculate how much it will go up. Clearly plus 20 centimeter it will go up. Is this clear what I am saying? You have done some such a question in SHM, okay, that what is the meaning of amplitude? Plus a, minus a, 0, plus a to 0, 0 to minus a. It keeps on moving between these 2 points, okay. So here it will perform SHM like this, okay. But anyhow, so you come to know that here whatever you are giving a compression, that becomes amplitude. This is the concept you should apply over here to solve this kind of question mentally. So if you say this is from natural length, this is mg by k, okay, and say for the time being I am saying L naught length, should I take this as L, because L naught generally I use for natural length, just a notation, it does not matter. So say it is L distance down, so L is mg by k, and this L value I am just for example I am taking L as say 30 centimeter, that it has compressed the spring by 30 centimeter, okay. For this you can calculate m and g will be given to you, and you can calculate, say k is 100 centimeter, 100 Newton per Newton example के लिए, और m I am taking here as 3 kg. So you can check 3 kg, okay, then 30 divided by 100 is 30 centimeters. So you will get like this, and you further pushed it by distance 10 centimeter. So this from natural length it will go to 40 centimeter, but from mean position it has gone to 10 centimeters. So maximum it will go up to 10 centimeter up. So still it is below the natural length. How much distance? 30 minus 10, 20 centimeter. So once you are compressing it, so I am saying L is 30 centimeter, I am pushing it further 10 centimeter. So 10 centimeter has gone down, so it will come up 10 centimeter. Okay, so 30 minus 10 is 20 centimeter, still below the natural length. So force will not be reversed. Now I will make it 20 centimeter. So I will push it by 20 centimeter. So what will happen? I know that if I am pushing it by 20 centimeter from mean position, it will go up 20 centimeter from mean position. Still it will not reach to the mean position. Why? Because it is 30 centimeter. So still it is below 10 centimeter. Now I will push it by 30 centimeter further and release. What will happen? Exactly it will reach to the mean position, natural length. It will exactly reach to the natural length. So if further I am pushing it by 30 centimeter, it will further go up to 30 centimeter. Is this clear? What will happen if I push it by 40 centimeter. If I push it by 40 centimeter, it will go from here 40 centimeter up. So it has crossed the natural length, and then the force will be in opposite direction. So it will pull it up. So whatever I am distance giving, that distance must exceed the natural length. Then it is possible that it will be lift off. So how to solve this question mentally, or just writing one step? This is the way to write. Have a look. Say you have pushed it by some distance x naught. So this has, from here it will go x naught up. Okay, you know that. Okay, here. If the arrow length doesn't look same, then you can extend it further. So this is x naught. So it will go x naught up. So say this mass has reached over here. Okay. So what is the force in this spring? Okay. So you can have a look that. We have already discussed that here m2. Okay. That this length, the extension from natural length should be equal to m2g. I have just written over here. When it is being lift off, m2 mass here, normal action becomes 0. When this force is equal to m2g. Spring force, F spring, I think I have written in this way. F spring is m2g. Then it will be lift off. And what is F spring? When it is going above the natural length. How much natural length it has gone above? K into x naught minus, you can have a look, x naught I have taken from here, and this length is L. This is the force. Okay, F spring. So how I have calculated F spring? K into extension from natural length. What is extension from natural length? X naught from here minus L, and that should be equal to how much? M2g. So this is the equation you should have written. Okay. So clearly this is Kx naught. I need to find out, minus KL. L value is mg by k. M1g by k. Okay, for that question I am just talking here. So this will be m1g by k equal to m2g. To solve that question, okay, here L is k, m1g I am taking because here I have taken m, so m1 I am taking now, m1g by k equal to m2g. K cancel out. So kx naught equal to m1g plus m2g. So x naught will be m1g plus m2g by k. So this is the answer. Okay. So is it clear to you what I have said? So you should have written this equation directly. Okay. And how to write this equation? I mean, just I am squaring. Okay. Have a look. K x naught minus L equal to m2g, and what I have used here, that is spring force here should as soon as it becomes m2g, okay, it will lift off. So what is the spring force? K into x naught minus L, and x naught is a compression from mean position. Look at this. And so from natural length, its length is x naught minus L. So we got the answer like this. So if I am going to give some question like this, you can solve mentally now by keeping this concept in your mind. Okay, like if a ball is dropped and it is hitting that, and then how much it will compress the spring, you can solve it by your own in this case. Okay, so I will give you one question, you have to solve it. Is this clear, this step, how to solve it mentally, this kind of question? So if it is given that M1 hello. Okay, so I'll give break now, okay, because I have explained this topic. I'm giving break for 15 minutes from now, and after that we'll discuss some question how to solve this kind of question mentally, okay, related to spring mass system where some mass is going to hit it further, okay. So, uh, okay, so you can give a break. So 15-minute break. Okay, welcome back, student. Okay, so just now I'm discussing this question, spring based. Now this is the question that you need to solve quickly. Okay. So this is the system given over here, that M1 and M2 is attached with a spring, and then M2 is removed. M2 is removed. So it's like this. You can have a look. If this is mass M1, I'm going to pull this. Okay, so only M1 is remaining. M2 has been removed. So M1 will oscillate. So you have to find out what is the maximum compression in the spring. Again I am repeating, there is a spring and it is attached with two mass M1 and M2. M2 can be removed. So now M2 has been removed. So what is remaining there? M1. So it is initially in equilibrium, M1 and M2, and this spring is of course naturally stretched down. So if M2 is removed, what will happen? This spring will try to, unbalanced force will try to pull it up. So it will go up to some height. So what is maximum compression in the spring? You have to find out. Okay. So try to solve this question. Okay, M2G by K. Mehul has answered that question. Is this M2G by K? Think. Okay, so have a look how to solve this question again mentally, this kind of question, keeping that thing in your mind, that what is mean position. When M1 and M2 is attached, okay, it is already it's already stretched down by a distance, say L, M1 plus M2 G by K. So this is natural length from where it has been stretched here. Once you remove this M2, okay, so now new equilibrium position or mean position will be at distance, okay, say L dash in new position is m1g by k. So once m2 is not there, you know that what is its mean position. Mean position means position where the force becomes, okay, means where forces are balanced. So m1g, okay, so L dash below that, okay, L dash is the distance from the natural length where the force m1g by k is a new mean position once m1 is there. So I am saying like this, say this is only m1 is there in place of m2, then this is natural length L naught and this is L dash I am talking about. So L dash is m1g by k. So initially it was here. For this given diagram, it was down, little bit down here, how much? m1 plus m2g by k. Okay, so once you release it, you know that this is extension from the, okay, mean position. How much extended from the mean position? You know that L dash is m1g by k and this one is how much? Here L is m1g by k plus m2g by k, this one. So if you look at this diagram, you know that, okay, here m1 and m2 are both are attached, okay. So you know that this distance, once it will go here, it is, so you can think in this way that it is being extended from mean position, new mean position m1g by k, a distance of m2g by k. So this difference is how much? Here to here, this difference is known as, okay, m2, say L double dash m2g by k. So make it very simple, not very complicated, that once m1 m2g is there, okay, the extension is m1g by m1 plus m2g by k, and when it is removed the new mean position in m1g by k, so it was further down by m2g by k, it was down from mean position. So from the mean position it will go up by how much distance in this case? m2g by k. So whatever the position here is, okay, it will, once m2 is removed here, it will, from here it will go up a maximum distance up to m2g by k. So this is the distance it is going up. So what is maximum compression it can compress up to? So whatever the natural length is initial position, from there it will go up to m2g by k. So this is a further compression, okay. I am not asking for compression from natural length, how high it will go? m1g by k. Okay, so this is the way to understand. So you can see that without applying conservation of energy or work energy theorem, okay, you can solve this question mentally like this. If a question is given like this, this is m, this is 2m, and this is 3m, okay, and then 3m mass is removed. How much distance m and 2m will go up? So can you solve this mentally? Hello? Okay. So question is, when 3m is removed, how high it will go, m and 2m. So total mass is m plus 2m, 3m, 3 plus 3m, 6m. 6m mass is there. 3m is removed, so 3m is remaining. How high it will go? So quite simple. Just think like this, that it is below by 6 mg by k. Once it is removed, now remaining is 3 mg by k. So 3 mg by k, okay, it will go up. So this is the way to solve this question mentally. Okay. So answer is here 3 mg by k, x naught, it will go up. and once you are removing this m and 2m and m together, you are removing it, how high it will go. So you can think in this way, it is a stretch by 6 mg by k and 5 mg by k it has been removed, so mg by k. So this will, whatever the mass it is removed, it will go up to that distance. So you know that equilibrium is mg by k and now before 6 mg by k. So further it is stretched by 5 mg by k, it will go up by 5 mg by k. So now finally you should remember whatever the mass is removed into g by k will be the answer. So 3m plus 2m is 5m, 5m g by k. So this is the way to solve this kind of question. Okay, now next kind of question. This would, okay, say this is mass m and another mass m, say clay, so E is 0 and this height is h. It's released from the rest, initial velocity is 0. Okay, so you have to find out, okay, that this mass will stick with this and they will compress down by some distance. Already it is compressed from natural length, but once this mass is going to hit it, it will further compressed. So you have to find out what is a compression in this spring. Find compression in the spring from this position, from given position. I am giving a name A, from A position. A is just a name of the position initially. So E is 0, so clay will come, hit and stick with the mass m and then both of them will go down. So how much it will push it down further from here. Okay, and of course I wanted you to solve it mentally. Okay. What is the answer of the last question? Last question I have given 2-3 cases, na? mg, m, 2m, 3m, one mass 3m has been removed, 3 mg by k. If 3m, 2m both are removed, 5 mg by k. This is the way to solve this kind of question. So here you try to solve this. Both mass I have given same first, so that you could solve it mentally, and then so find out what is the maximum compression or what is the compression in the spring from A position. A is the initial position. see, if we don't just if you are keeping, so I'll tell you when to solve this question mentally and when you have to write the equation. Once it is given that there is no height h initially and it has just placed gently over here m, just placing it m. So you are not striking it, just keeping it gently over here. How much distance it will go down further? So for this question you can solve mentally because you know what is the trick to solve. Just now you solve some question that its mean position is mg by k down, from natural net it is mg by k down, but as soon as you keep mass m further, then the new mean position will be 2 mg by k. So from mean position it has gone further by mg by k. So simple enough you can say mg by k it will further go down. So it's so simple. If you are adding or detaching masses, this is the way to sum. So whatever you are adding, that mass mg by k, and whatever you are removing, that mass into g by k is a distance travel further. But for this question where it is released from height h, it's a question of collision, where you have to find out. So this kind of question is given in Erodo book. So you can, in place of mass m, they have given a pan of mass m, and then another object is released, but still we try to make it simple and try to solve it quickly. So here you cannot solve this mentally because it has already gained the velocity here when striking, and here when it is reaching here, its velocity becomes v equal to root 2gh, because initial velocity is 0. So no need to prove this, you know that once it is dropped by height h, when it is descending the height h, the velocity becomes root 2gh. You can apply v square equal to u square plus 2as. V square equal to u square plus 2as. So initial velocity 0, 2 into g into h. So v will be root 2gh. Here it is. So now after hitting it, now they will exchange the momentum. So before the spring is further compressed, let them change the momentum. So this is the concept that is very important, that when it is striking it, at that moment spring is not compressed. First the momentum will be exchanged. After exchange of momentum, then spring will be compressed. So this is the ideal case you should know. Otherwise students think that as soon as you touch it and then spring is being compressed, then spring will give us external force, I cannot apply conservation of momentum. So what is happening in any kind of collision case, before any spring which compressed further, they have to exchange their momentum first, because it is happening very quickly. So first find out what is the momentum, just after hitting it. So initial momentum is m into root 2gh, plus m into 0. So this is momentum just before collision, and just after collision, this will be the same. So why I am applying conservation of momentum even in vertical direction? You might be thinking that mg force is present over there. So if force is present, then you cannot apply conservation of momentum in vertical direction. So here even you can apply, even on this force mg and mg is there. You can have a look. So if I am asking what is external force on this m and this m, you can say that on this mass, this is balanced mg and spring force. But this mg, when you are going to hit that, it will get the external force because of mg and spring force also. So the thing is that still how can you apply conservation of momentum in vertical direction? What is the and that is right. What am I explaining? That is right. You can apply conservation of momentum in vertical direction. Thou it you have been you have been taught like that, that if the force is absent, dp by f is dp by dt. If net resultant force is 0, then differentiation of anything becomes 0 if p is constant, p is momentum. So you can apply conservation of momentum if force is 0, and here you can say that when it is going to collide, they have an external force of mg. How can I apply conservation of momentum? Answer is that because it is colliding for a very, very small time dt. As soon as they collide, you have to take the assumption that they have extended the momentum and then going further down. So in that external force in the time dt, mg force, because of this there is gravity. So velocity change will be g into dt, v equal to u plus at, g into dt. This is almost negligible because dt is very, very small. So you say that external force is there, but because of external force, okay, the considerable change of velocity is not there. So I can apply conservation of momentum because this external factor is not increasing so much velocity. Okay, got it what I am saying here? So velocity is 0. So in dt time, velocity due to the gravity increase g dt is very, very small, say microsecond, millisecond or nanosecond, this is very, very small. So we compare to a collision velocity which is quite high in this case, okay, you can apply conservation of momentum. So this is the reason behind that you can apply conservation of momentum in vertical direction, okay, that's why given this concept. M into root 2gh plus m into 0, this is the collision just before that, and say it takes very, very small time dt. So after that g has no effect on that, okay, so it is as good as they are, okay, colliding in free space, like in space free gravity is not there, so it's a gravity free space there, and then they are colliding like this and they are going down. So you can think in that way. So this is equal to, okay, m plus m into v common, vc, okay, because E is 0, so what will happen in this case? They will stick with each other, so combined mass will become 2m into Vc, so Vc will become root 2gh by 2, okay. Okay, so Vc root 2gh by 2. So this is the velocity. So this is one important concept that you can apply. Don't get confused in exam that I cannot apply because external force is there because of g dt, okay, negligible velocity change, that's why you can apply conservation of momentum, okay. Now next point that you should think is conservation of energy. After collision, during the collision energy is lost because g is 0, but once they have become a system, m plus m, 2m has become, after that you can apply conservation of momentum. Why? Because after collision, okay, naturally there are two forces, spring force and 2mg. mg is also in this case what is a conservative force, so you can apply conservation of energy or work energy theorem. So here their velocity becomes Vc, which I have written over here, and somewhere here it becomes, velocity becomes 0. Velocity becomes 0 because once it will compress, it will stop here. So you can apply change in kinetic energy 0 minus 0, sorry for this, change in kinetic energy 0 minus half mvc square. So here velocity becomes 0 and here velocity is, okay, Vc, but mass has become 2m. So half into 2m into Vc square, that is equal to work done by all the forces. There are two forces, okay, one is mg, 2mg. So work done by mg will be how much in this case? 2mg into this distance they wanted to know, say this distance is x, okay. So it has gone by distance x. So total work done in this, so mass has become 2m, so 2mgx minus half kx square. Is this wrong? Okay, so we'll think about this. Okay, first, but make it so that this is positive. What is work done by the spring force? Okay, and it's not very difficult. You can think carefully. What is the work done by the spring force? What do you say? I have explained it very clearly what is work done by the spring force. Half into k into x square. You think about x only. That's all. Okay. Is there any question till now? And then I will further complete. First, you think about x. See, this is what I am finding out, the amplitude. Okay, I will come back to that question. Okay, first let me explain that here. What terms you should write here to solve this. First important thing you learn here is that you can apply, okay, conservation of momentum even in vertical direction because collision take very, very less time, and in that time, okay, velocity doesn't change, first thing. Second thing, spring does not get compressed. First they exchange their momentum. So they are exchanging the momentum. Till there you can visualize that this spring is still there, it's not being compressed. So it's not happening simultaneously that this process has started and this spring is being compressed. So this is the one things you have to take because of inertia in this case. Because of inertia it will remain in this state. Spring sudden change will not make it change it very fast. So this is Vc here, okay. So 2m and we see there how much, and say from here it has gone by distance x. So you need to find out there half kx square, of course minus half kx square because force is in upward direction. Okay, what is x stand for? Let me see how many of you are. You have to fill in the blanks. Anyone? And then you can solve it by SHM. I will explain that also. But I need to first discuss the important concept. Can you apply conservation of momentum? So I am going by this way. Okay. And then applying work energy theorem or conservation of energy, it doesn't matter. Where half kx square, where x stand for, okay, extension or compression from natural length. Let me see how many of you are telling me right answer. What is their question mark? You can see now what is the, you have to fill in the blanks, that one question mark. What is the terms over there? So already when before the collision, already it is compressed by distance k L equal to mg, L equal to mg by k. Write this. So should I take here mg by k plus x the whole square? I am just writing, maybe it's not right. Will you correct me? Or you think this is right? Right or wrong? Just you can write down here. Is it mg by k plus x the whole square by looking at the diagram, or something else over there? So still this term you have to think, is this right or wrong? X minus L. It should be plus, na? Because it must, see half kx square, x stand for extension or compression from natural length, don't forget. So what do you say? Is it mg by k plus x the whole square, or not mg by k plus only half kx square, or something else? Okay, if x is compression from natural length, then mg by k should not come. No, already mass, just a minute, Rohit, you can have a look that in this question, okay, the clay, before clay is hitting, it is already spring is compressed by length L, and L is mg by k. And once a clay is hitting that mass m, okay, will it further compress it by mg by k to mg by k, or it will still remain mg by k plus x the whole square? So this is the question I am asking. So let's see which one is right, mg by k plus x the whole square or 2mg by k plus x the whole square. Here you have to think. Okay, so again I am going to tell you what I am saying here. Actually, here, see this clay has not been released. Okay, you are holding it at distance height h. So this was the natural length, say spring length here. Okay, natural length. So it has come down from natural length. Here I will write natural length. It is already, okay, compressed by length L, where KL equal to mg, so L is mg by k. Okay, so if you go further x, the answer will be, extension from natural length will be mg by k plus x the whole square, which I have writing over here. Okay, so once you look at this diagram, you will feel that, okay, once it is going further x from here, okay, the answer will be this much. So once, but the confusion arises here that when this mass is released, it will going to hit this mass m. Okay, just I am showing dotted line here. So once it is released, its velocity will be root 2gh, and after, okay, exchanging their momentum, they will move with the common velocity root 2gh by 2. This is quite clear to you. They will move with the common velocity. So at that instant, is this spring length has changed? Has it become 2 mg by k because now mass has become 2 mg, or is it still mg by k there? So this is the question I am asking you. Make it very clear about this. So are you clear what I am asking the question? Okay. Should I write this as mg by k or 2 mg by k? Now why 2 mg by k? Because our mass of this clay has come and hit that mass. Okay. So it has given its load also. So do you think that? Okay, so Iraf Hassan said it's mg by k plus x the whole square. Okay. Everyone please let me know what is the answer. Mg by k plus x the whole square or 2 mg by k plus x the whole square. One of them is right, but you convince yourself which one is right. And I have given this answer while discussing this theory, conservation of momentum and exchange of momentum. I told you very one important thing. Don't miss that, otherwise you cannot answer this question. Okay, Rohit has also answered mg by k plus x the whole square. Iraf has also answered. Anyone else? Okay, so I am giving the answer now. Don't forget whatever I am discussing. Okay, listen carefully. This answer is mg by k plus x the whole square is right. Why? Because it has no time to compress it up to 2 mg by k. If you are placing it mass m gently, then it will go up to 2 mg by k and stay there. But what is happening that when it is exchanging the momentum, I told you that when they are exchanging the momentum, okay, there is interaction between these two masses. Spring is still unstretched. So that is, it is still L below, which is mg by k, and then further Vc will try to push it down. So actually if you look at from natural length, okay, when they are exchanging the momentum, this mass is not compressing it further. That mass is only interacting with m, and they are interacting with each other, and they are getting there, changing their velocity, like root 2gh has changed into root 2gh by 2, like this here. Okay. During that process, the spring has not further compressed. So I told you earlier also that when they are exchanging their momentum, spring is still at the same position. After exchanging their momentum, they will go further down with Vc velocity. So what is the extension from natural length? So I am applying a conservation of energy from this position to this position. Of course, here it is there. So in this case, you can have a look that from this position to this position, here what is the momentum change? 0, here it will become 0, minus half mvc square equal to 2 mgx, because once it is coming down, the mass has become 2 mgx, but extension from this position to this position, L plus x the whole square. So this is mg by q plus the whole square. So this is right. So what important thing I wanted to make it clear to you, that when they are interacting m and m, okay, spring is still it's in the original position, and after exchanging them their momentum, they will further go down. So this is right. Is this clear to you now? Okay. So this will become minus m, and Vc square from here is 2gh by 4, square it, 2gh by 4. I am just keeping this value here, just okay, that is equal to 2 mgx minus, you can open this bracket, okay, half k, first expansion of this, okay, and then squaring it both. So have a look. So mg by k the whole square, okay. This, if you want, you can write this as L and later you can expand it further. It's okay anyhow. Okay, have a look. So this is the equation you need to write. Let me solve it further. So we are discussing, okay, the case of collision, and then we wanted to know how much this spring is being compressed. Before I didn't give any question of collision, just there you are gently pulling the mass, okay, or you are gently placing the mass. Here it is a collision is happening, and in collision happening, this point must be very clear that it is mg by k plus x, because during their interaction spring is not changing its position, okay. Okay, after knowing this, you can solve some good question based on that. Otherwise, always there is confusion to solve this. Can I apply conservation of momentum? Should I take that? Should I consider this mass m also or not? Okay, that's why I took some time to illustrate that point. Okay. Okay, so I will solve it further. Minus mgh by 2 equal to 2 mgx minus half k. If you want, we can multiply both side by 2. That will be better. Okay, so multiplying both side by 2 first. So this will be minus mgh. Multiply this side by 2 also. This need become 4 mgx. Multiply this by 2 also. So this becomes k. K, and then open the bracket, k into mg by k the whole square plus kx square plus 2k mg by k x. Okay, so here k cancel out, this is 2 mgx. So this becomes 4 mgx plus 2 mgx, 6 mgx. Okay, so and this will be a constant quantity which you can bring it up to here, this side. So overall this quantity becomes x square, that part kx square, this kx square plus this terms 2 mgx plus 4 mgx is 6 mgx. Okay, and then this term you can bring it this side, okay. Or you can bring mgh into that side, so that I could write the quadratic equation. So mgh minus, if you want, you can cancel this part with k square, so this becomes m square g square by k, okay, that is equal to 0. Check this step. And then you need to solve this quadratic equation, which will be, okay, in this case you can have a look. If you divide it by k both sides, it is x square plus 6 mg by k x plus mgh by k minus mg by k the whole square equal to 0. So divided both sides by k, this form. Okay. Okay. If you look at this mg by k, it is L actually. Okay. And then you can solve this further. X is given by minus 6 mg by k. Here I have written plus minus under root b square this is b square 36 m square g square by k square, okay, minus 4ac. So minus 4 into a is 1 into c. Okay. By 2a. Okay. So minus 6 mg by k plus minus, and let's see this bracket, 36 m square g square by k square, which is 6 mg by k the whole square, okay, minus 4 mgh by k minus 4 mgh by k plus, okay, 4 mg by k the whole square. Okay. So it is clear, minus minus this is plus and 36, this becomes 40. Okay. And this is 4 mg by k divided by 2a. And further, how will you solve it? Okay, just after this, minus 6 mg by k plus minus, okay, root 40 mg by k the whole square, okay, minus 4 mg h by k upon 2. So already you can have a look here. In this case, this is plus and minus. This is telling you, okay, as you know that this x is taken here, clearly x I have shown you from mean position. So it will minus of minus this one and plus 1. So this is showing that how far it can go up from the mean position if you are taking the plus sign. So minus 6 mg by k minus of this will give you the value how much it has gone down in this case here. So this is going little bit complicated, okay, but this is the way to solve the question. Okay. So here, is there any shortcut technique to solve, because it's going very lengthy? You need to solve it by quadratic equation and so on. Okay, so how to understand, okay, how to solve this kind of question? Okay, so don't you think it's going very lengthy? Though its question is solved because it's a quadratic equation, it's another thing that I'm getting this equation very lengthy, but all are known terms to us. Okay, and these terms you can check here. Okay, this term is positive, you can have a look. If even this h is 0, if you are taking h equal to 0 in this case, you can solve this further, what is the answer that is coming out to be in this case. Okay, so x is taken from the mean position, so it will tell you which one answer is right here, plus or minus. So you have to think here one point, that what is the minus sign gives you here, which displacement, which one is right, or with the plus sign. Okay, so this is the thing that you need to think, but before that, okay, I will tell you what is the way, okay, to solve this kind of question quickly, okay, rather than writing so much equation. But I have already explained you in order to tell you that when you can apply conservation of momentum, should you consider the compression of the spring or not, whatever I have discussed, that is right, okay, and this is the answer that I am getting here, which is complicated, but one thing is not clear, which one is right, plus answer should I take or minus, soon it will be clear to you, I will tell you, okay. So okay, so this is a question from Eurodo. Okay, you can check that book, okay, and you know that generally their answer is very complicated, but there is some way to solve this quickly, okay, and the technique is same that I told you. You have to find out, okay, further compression from the mean position, okay. So should I tell you what is the way to solve it quickly? Okay, I will also make it clear which one is plus and minus. Have a look. So I am just going to rub because I hope you have noted it down. That's why in the beginning we don't advise a student to solve Eurodo book, I mean all the questions, okay. Later if you want I can mark some questions from Eurodo book, okay. You don't need to follow. Next, if you want, I can give you which question you need to solve, because all the questions are not relevant for IIT JEE mains and advanced examination. So if you want, I can give you the list of the question, okay, where you can mark those questions and try to solve those questions. Unnecessary, you don't need to solve all the questions, okay, because it requires the concept of higher mathematics, engineering mathematics, okay. So now, looking at this expression, I know that it is quite discouraging because it is lengthy, very lengthy equation, and also at the last step you don't know which minus sign should be taken or plus sign, okay, but it will be clear to you soon in this case, okay. So you just try to see this kind of question you have already solved, okay. You can see a C. Verma book, okay, where mass m is moving with some velocity v, this is mass m, this is k, okay. So why don't you solve this and then get the idea for that question, which is collision happening in vertical direction. So initially you try to see this question, how much it will be, how much further distance it will be compressed, you have to find it out. And since there is no gravity involved over here, because gravity is being balanced by normal reaction here, so only there are this is exchanging momentum in horizontal direction, and if it is coming with velocity v, what is the maximum distance it will be compression it will happen. After understanding this point, you are able to solve that question that I have given just now. You can solve it by writing few steps. You cannot do it mentally still, but you have to write a few steps over there. So have a look. So first we will try to solve this question. It's quite easy for you. So what you have to find out, it is moving with velocity v, what is the maximum compression in this spring. And believe me, that question could be solved very fast once you are able to solve this question. Okay. So can you please, because time is less, we need to wind it up. Okay. You try to take the help of that thing that E is 0 in E, okay. Take equal to 0. And later as a homework I will give you when E is not 0, okay, what will happen. Okay. So further I will tell you how to think about this question m, this is k, and this has given some velocity v. Okay, this question certainly you can solve, and then I will come back to this. Okay, I will take only 5 minutes to discuss this quickly. So once you are giving this velocity v, and this is at natural length, okay, this is natural length L naught, then what is the compression in the spring? Simply you can apply. So you can think like this: you are giving a velocity v to the block directly by hand like this, and I am asking what is the maximum compression in the spring. Apply work energy theorem. Here change in kinetic energy is 0. Somewhere it will stop here, say, here velocity becomes 0, 0 minus half mv square, and this term you can remember or you just know how to write the step. 0 minus half mv square equal to work done by the spring force only. Why? Because there is no gravity working. It is balanced by normal reactions in this direction only. So this is m half kx square. Okay, now plus half kx square or minus half kx square, quite simple. Once you are giving a velocity v, displacement is in the left hand side, but spring is compressed, so it will give you the force in right hand side. So once you are compressing it like this, force will be to your right hand side, displacement in left hand side, so this is also minus. So this minus minus cancel out, half cancel out, and then x here is given as mv square by k under root, which gives you m by k into v. This is known term to you, root m by k into v. Okay, so once you know this root m by k into v, you can see that how this question can be solved it quickly. Okay, and then you can correlate that question that I have given to you. Okay, you have to, as a homework, that you have to find out what is the value of x by this way. Say now this is v. So this question and this question is almost same, you can think, but let them collide first. If their collision is happening here, their velocity will be m into 0 because it is at rest plus m into v equal to, they will stick with each other because e is 0, 2m into vc. So here vc will be mv by 2m v by 2. So it's become same thing. What is the same thing over here? That it becomes here v by 2 and here it is v. So you can think like this, in place of this v, when it's colliding, its velocity becomes v by 2. Okay, so x will be, in this case, by solving this, x will be given by, okay, now is it v under root m by k v or is it be 2m by k into v? Let's try to see this. So once you are applying same conservation of here work energy theorem, 0 minus half, you have to write here as 2m because they are going in vc square, which is v square by 4. So change in kinetic energy, okay, equal to work done by all the forces minus half kx square. Okay, similarly minus minus cancel out, half cancel out. Okay, and this you can have a look here, what is the value. So here k will be come to this side and then x will be 2 mv square by 2k under root. Okay, so this will become m by, check here, half of cancel out, and yeah, 2 mv square by 2k. So check this value. Okay, so here this you can have a look that it has changed the value here, m by 2k into v. So it is not 2mk into v. So you can check what thing has changed over here in this case. Okay, one is velocity and one value is this here. So this is the actual method to solve the question, which is depending on the mass and E collision, it keeps on changing. But there is certain way, which I am going to explain next class, where you can solve this kind of question, collision question and this block question, okay, easily. Not mentally, but you can solve it easily by knowing some step. So here I have shown you difference in this case. What I am going to do, that I am going to give you the homework, okay, and what you have to find out, okay, let me tell you. You have to find out that what is generalization of this formula by taking this as m1, this is your homework, m2, this is v, and e as e only. Okay, don't take here e as 0 or e as 1. Okay, say e equal to 0.8, 0.7, something like this. So first you need to solve this question. Okay, for your convenience, if you want, you can take this e equal to 0 initially, and later you can compare when e is given and make a generalized formula. Then I can discuss next time how to solve a question based on that when collision is happening in vertical direction without writing a very long expression in that case. Okay, so is this clear what I am saying? What is homework? So this is your homework. First case, when e equal to 0, okay, find the mass. I am giving you a hint, m1, m2 upon m1 plus m2 will come in this case. okay, which I will explain, and second case when E as E, don't take it 0. So solve this, and what you have to find out? X for both case. X1 means for first case, and second question is X2 when E value is there. Okay. So this much you have to be ready next class. Okay. Then I can tell you a method, shortcut method to solve, okay, this kind of complicated question in a few steps. Okay. So see you next time. Okay. If you have any question, you can type it over here. I think some student has some doubts. They can ask over here. I can explain. Okay. So see you next time. Bye. Dipesh, I will explain that part. There is plus and minus sign. Still, I have not made it clear to you. I told you in next class I will explain it. Okay. But before I could explain, okay, you need to solve this homework. Okay. And here, yeah, of course, this is not a formula I am asking you to memorize. Okay. I wanted to make some concept clear about the collisions, so that it's not very confusing. Next class it will be very clear to you, like other topics. Okay. So collision, see why collision question is little difficult when spring is involved. Okay. For this you need to know one frame of reference, that is called center of mass of frame, which I am going to discuss next time. Without learning center of mass frame, it's very difficult to solve spring and mass question, okay, and collision questions. So you have to wait for the next class. Irafo, okay, you wanted me to, yeah, you told me a question based on block against the wall, right? Okay, so what will I do? That I have still 7:30 it will go offline, this class. So I am going to tell you rough the doubt that you have asked. Okay. So rest can leave because Raf has asked this question. So say first single block question. Okay, so Iraf, I'm going to explain this question. You are feeling difficulty to solve the question based on, okay, a friction against the wall. Okay, so let me explain this question. Okay, so first you can say that if I'm taking a tester and keeping here along the board, you can see that it is coming down, right? So I will compress it. I will give the normal reaction like this. See, the now duster is not falling down. So this is the same question that I have given to you. So what has happened when I am giving a normal reaction here? This normal reaction has no role to balance the mg of this because it is perpendicular. But it will give a normal reaction N, and N is given here as 60 Newton. You can have a look. If this is normal reaction in right hand side, so N equal to 60 because block is not moving to left hand, right hand side. So here FL will be equal to 0.5 into 60, 30 Newton maximum it can provide in order, okay, so that it doesn't slip down in this case. So naturally what is the force here? 40 Newton, 60 Newton and this friction. So what is this friction? You can have a look. 40 Newton, only this can be balanced by friction force, not by 60 Newton because it is at 90 degree. So, but is it sufficient to balance it? Its answer is no, because here maximum friction can reach up to 30 Newton. So 30 Newton force will be in upward direction, so this block will go down and its acceleration will be 40 minus F. Now we know the nature of F because FL 30 Newton because it cannot overcome 40 Newton. So 40 minus 30 equal to 4 into A. So here A in downward direction will be 2.5. Okay. So this will be the acceleration and friction force will be 30 Newton. Correct? Now same question, I am changing a data a little bit here. 4 kg, mu is same again 0.5 and here a force applied is 100 Newton. So once you are applying 100 Newton, now you know that here FL will be equal to 0.5 into 100 will be 50 Newton and here force is 40 Newton. To stop it, it need to apply here 40 Newton. So friction force in this case will be 40 Newton. So it will not go down because it can provide up to 50 Newton. So here no acceleration, A will be 0 because 40 Newton balanced by 40 Newton and F will be 40 Newton. What will happen if I increase this value 100 Newton by say 150 Newton or 200 Newton? So if it increase by 200 Newton, this will increase, it will become 100 Newton, but still friction force remains 40 Newton because it will not slide over here. So once you are applying a force, here some force such that this is balanced 40 Newton. So this friction force will be equal to applied force. You can have a look, 40 Newton always. So up to at 100 Newton, it is 40 Newton, 200 Newton, 40 Newton. So at what force you should apply here, generalization, F, such that it does not, just it's not falling down. So this friction force must be equal to 40 Newton, then it is not falling down, and you know that this friction force is given by mu is 0.5, mu into n, 0.5 into n is F, and friction force is how much? 40 is point F, so F will be 40 by point half, that means 80 Newton. So at 80 Newton this block will stop. So if this is the maximum force, minimum force you should apply in order to stop the block, 80 Newton. If you apply more than 80 Newton, friction force will be fixed, 40 Newton. If applying lesser than that, friction force will be equal to maximum friction force, which is equal to whatever the force applied over here. So have a look what I have said. So for this 80 Newton is the minimum force in order to stop the block. If you apply more than that, good enough, it will be always not moving at all and friction force be equal to 40 fixed in this case. But you are applying lesser than 80 Newton like 60 Newton over there, you can see that what is the acceleration and what is the friction force. So friction force in that case is coming out to be 30 Newton. So this is the question based on the block. So you should take this 2-3 example to understand this part. And then I will tell you what is the 2 block question in this. So here is one question you can quickly solve and let me know whether you understood or not. Say this is 6 kg, mu is 0.7 and applied force is 80 Newton. What is friction force and acceleration? Solve it quickly. So my name is Siddhi. I am not able to solve most of this because I feel very see, physics is a kind of subject which is very, very conceptual. It's not like that you are solving lots of questions, then you will get the confidence. It's a concept that you have to grasp. In order to grasp the concept, Siddhi, I am talking to you, that you need to go systematically. First you have to understand, first you get a good command over integration and differentiation and vector questions. If you are finding difficulty in calculus questions or vector question, it will be very difficult for you to solve further question, because because class 11th is not an extension of class 10th, as you know that, because concept is totally different here in this case, because calculus is being used in this case. So one possible reason could be this: you are scared of physics because the basic vectors and calculus are not very clear. And apart from that, you should also try to start solving question from the beginning. There is graded question given in CL booklet, DC Pandey book, okay. So first try to solve those questions based on similar concept. If a spring question there, solve all the spring question, and then try to solve mix-up question, because in JEE mains, okay, there is 1 or 2 level of thinkings are there where they will mix up a spring with blocks, and then in advanced question they can just now have given that question, a collision question they can give. So you can get the command gradually. So you start solving graded question first. Okay, and if you have any difficulty, you can talk to your teacher also in this case. You can, for basic things, you can talk to Bhaskar sir, he is going to help you out, okay, to understand the basic concept. And if you wanted a application of this kind of concept you have getting in this case, you can ask it to me in the class. Like just now I am talking about, okay, this friction against the wall. Okay, so if you have any doubt like this, you can let me know, I can discuss with you. Okay, now I have got some question here and answer. Yeah, 56 2 by 3. Okay, all right. So many of you are able to answer this question. Have a look. So if here FL will be equal to 0.7 into 80, 56 Newton, and here it is 60 Newton. 56 Newton cannot stop this 60 Newton, so it has to come down. So it will apply a maximum force of 56 Newton here. So acceleration will be 56 by 6a. So a will be 4 by 6, 2 by 3.66. Okay. And here friction force is 56 Newton. So this is the way to solve this question. Main challenging question comes when there are 2 blocks. Say 5 kg, 3 kg, and mu is 0.5, and see here mu is 0.6, okay, here. And given force over here is say 50 Newton, 60 Newton again. So, I think you are comfortable enough to solve a single block question against the wall. If you are keeping 2 blocks, which block will slide over here? You can have a look. So naturally this force is 50 Newton, this is 30 Newton, this is 60, this friction force. Okay, so friction force will always try to oppose the motion of 50 kg because immediately 50 Newton is down. So you know that this FL, I am just writing here F, and here FL is 0.5 into normal reaction is 60. So here FL is 30 Newton. Maximum wall can provide friction 30 Newton, and here this 5 kg and 3 kg FL is equal to 0.6 into, again normal reaction is 60 because 3 kg is not moving to left and right. So that means N equal to 60. Okay. So here I am just removing, you know this point, 36 Newton. So between 5 kg and 3 kg, the friction force will be equal to 36 Newton, you can say, and here it is 30 Newton, you can give in this case. But in this kind of question, the main challenge comes when how to know what is direction of friction on 3 kg and 5 kg. In case of wall, it is quite clear. Wall will try to oppose the motion to go down. The block cannot go upward direction, it's quite clear, it cannot climb by itself. So here friction force is in upward direction given by the wall. But what is the friction force on 3 kg? It is downward or upward? This is the main thing that you should know. Okay. So how to know what is the direction of friction force? So you will decide like this. Say like you will say like this, 30 kg is going down. In this case, this going down. So this friction will oppose it. So it will get it back here. So if so it's the friction force is always opposite to the relative motion or relative acceleration in this case. So once you are feeling that 3 kg each has tendency more acceleration than 5 kg, it is going down. Okay, so friction force is in upward direction, and so by Newton's third law, this will be in this direction. Or otherwise, you can think in this way also that if 5 kg is going down in this case, then 3 kg will try to oppose it into upward direction, and then 3 kg will get in downward direction. So this is a very, very confusing point over here. So how to know that 3 kg is sliding on 5 kg or 5 kg has more tendency to go down here? So this is the challenge, that is this kind of question, okay, that is important for this, okay. So in 2 block question, again I am repeating what is the challenge over here. say for the timing there are two cases only. I am making it very simple for you. It's only two cases are there. First case, 3 kg has more tendency to slide down compared to 5 kg. Say, okay, it has more acceleration than 5 kg. So if it is coming down faster than 5 kg over here, okay, then friction force will be in opposite direction to oppose it because it is moving faster than 5 kg, and so by Newton's third law this will get it back. First case. Second case, so 5 kg and 3 kg, assume that both are same diagram. So here if it is 5 kg is more tendency to go faster than 3 kg, okay, then 3 kg will try to support it, giving a friction force in opposite direction, and this will get in this direction. So these are two cases. Which one is right? This is the most important thing that you should know. Okay, what do you say? Okay, so here, okay, here these two cases I have shown you. I will show you how to solve this. Out of these two, let's see which direction of friction is right. This one on 3 kg in upward direction or downward direction. And I told you that it depends on how relatively which one is faster moving. Relative to 5 kg, 3 kg is moving faster, or 5 kg is moving faster downward direction. Okay. So this is that's why this is important concept, and here everyone, I mean initially also I used to stuck in this kind of questions actually, because it's not very clear which one is providing to whom in this friction force. But now I can tell you how to solve this question. Have a look. If you are applying a 60 Newton force here, okay, and this force is upward, only two cases are there, so I am discussing both cases. So here I have written all the data over here, you can have a look, and similarly for here, okay. Here if I am going to write the equation and I am writing that F is in upward direction assumption, then its equation will go like this: 50. You can say like this. If I am asking what is net resultant force in downward direction, so you can think in this like this: 50, 30, 80, and this F and F will cancel out. So as a system 5 kg and 3 kg, there is net resultant force of 80 Newton. Similarly for this also, 50, 30, and this FF will cancel out again. So if I am asking in both diagram what is net resultant vertical force in downward direction, your answer will be 50 plus 30, m1g plus m2g, anything you can say, 80 Newton, okay, will be the downward irrespective of the direction of this force, because anyhow they are pairwise force, they are cancelling out. One force, ground wall will give a friction force over here, you can have a look. So you have to write like this, okay, 50, I am taking this first case, 50 here plus F, because both are in the same direction, minus F wall, okay, given by the wall. In this case I should write FW, okay, equal to this three forces, two are downward forces, one is upward, equal to MA. Okay, so I am assuming that this A, they are moving together, 5 kg and 3 kg. So what is the equation for 3 kg now? 30 minus F equal to 3A. Okay, you can see that this is cancelled out. So this is the net resultant force, which you know already, that FF are cancelling out here by equation or by mentally also, that FF cancelling out. So 80 minus opposing force is FW equal to 8A. And FW here maximum, you can have a look, it's reaching to 30 Newton. So once they are coming down, we know that it is coming down, so FW is known to us, which is 30 Newton here according to this. So here I am writing 30 Newton. So here A will be 50 by 8. Okay. So you have to see the both assumption, which one is right. Okay. So you can have a look that here A is coming out to be 6.25. If they are moving together, their acceleration will be 6.25 according to this friction force diagram, not this one. Let's see whether it is right or not. We'll substitute the value over here to know, can it provide this much friction? 30 minus F equal to 3 into A. A is 6.25. So F will be 30 minus 18.75, which is 12.11.25. Have a look. So friction force is coming out to be whatever assumption is there plus value 11.25, and indeed it can provide here. You can have a look friction force. What is the friction force between 5 kg and 2 kg? 36 Newton can be provided. So indeed they are coming down, and friction force between them is 11.25 Newton. Check. What about this if I am going to use the same way by this way? Let us see what contradiction is coming. So here answer is like this, whatever I have taken the assumption, that turns out to be true, because here F is not negative sign, here it is coming out to be positive sign. That means indeed it is going down, and friction force, because it's this much friction it can provide here. So overall friction force here will be, F wall will be 30 Newton. Between this it is indeed upward direction here, and this is in downward direction. So and acceleration is 6.25. Why this will not work? Let us see. If I am going by this method, my equation will be go like this: 50 minus F minus Fw, which I known to us 30, okay, equal to 5a. Okay, just have a look what is the difference. And for this 30 plus F, both are in downward direction, you can say 30 and F. I should have written here F. Okay, that is equal to 3a. Ff cancel out, 80 minus 30 equal to 8a. So a is coming out to be 50 by 8, same thing, 6.25. So what will you say? Even you don't need to write this, because we know that this F and F cancelling out. Okay, so overall this will be the acceleration in any case, because F and F are finally cancelling out. But still I am writing so that I could check F. So here F value is coming out to be 3a minus 30. So this gives us 18.75 minus 30. Okay, so this is minus 11.25. So which is corrected me that friction force we have taken wrong. If they are moving together, this would, okay, this would be taken here as minus sign, means it will be in not in downward direction, it would be in upward direction, and this support will be in downward direction, which is coming in this case true. So you should not worry about here what is the direction of friction force F here. Okay, you can solve by any way, okay, and you will get minus sign and plus sign will make you correct in this case. Okay, so this is a case that you should know. But if I am going to change the value here, some new kind of cases will appear, which I am going to give you as a homework. You can try some question. So now you know how to solve this kind of question both way. Okay. Okay. So here I am just, what is force F applied minimum for which they are moving together? So how will you solve this question? Okay, they are not sliding over each other, and then maximum. What is your answer in this case? Okay, so at what force they are moving, okay, together in this case, and answer is here somewhere. So try this. What is force F, I am not removing minimum terms, F only, for which they are moving together, 5 kg and 3 kg like this together, but they are not slipping over each other, 5 and 3 kg, they are not sliding over each other. So we had to, you need to see here, follow this diagram and write the equation. And now you know what is the quickest step to write in this case. A is 80 minus 30 divided by 8. So what is F for which they are moving together? Okay, so what is acceleration? 80 minus Fw 30 divided by 8, 6.25. Okay. Okay. Now, if you apply a force F over here and they are moving together, their common acceleration will be 6.25. Now write the equation. Here 30 minus F equal to ma, and this A is 6.25. So this F will be 30 minus 3 into 6.25. Okay, but you can have a look that whenever I am taking this 30, this is for 60 Newton. Okay, but here I have changed the data, so you can say that here whatever the data I am reading 60 Newton, you have to write this as 0.5 F. Okay, FL is 0.5 F. So one changing is here A, just I need to write it again, I just made a mistake. 50 minus 80 minus 50 plus 30, 80 minus this Fw. Fw is how much? 0.5 into F upon total value. You can have a look. So what is the mass in A? 5 plus 3, 8. Okay. So overall you can have a look that this is 80, 50 plus 30, 80 minus F equal to m into A. They are moving together with acceleration A. So combined mass is 8 kg. So this is 8 equal to A. Okay. And then this equation will be 30 minus F equal to ma, and this is 30 minus, and they are, and here I am asking here what is the value of A, that they are just moving together, that means it has reached to its maximum value. So here F has reached to it, so it is going very faster, say like this. So this has reached to its maximum value, so that is 36. So you can have a look that what is happening in this case, 30 into, check. So here is some contradiction coming. So I told you that if I am going to change the question, it will be become a little bit difficult for you. It means if they are moving together with some force F in this case, this is coming out to be some minus on, just let me solve it, you will come to know, but anyhow minus 6 equal to 3 into 80 minus 0.5 F by 8, 3 2 ja minus 2. So this is minus 2 into 8 is minus 16 equal to 80 minus 0.5 F. So 0.5 F it will be 80 plus 16, 96. So F will be 96 divided by 0.5, 192. So at 192 Newton force, okay, up to them they are moving together. Okay. So if you are applying 192 Newton, they are still moving together, 192 Newton, and force is in this direction according to this equation. You can have a look. Okay. So check here, friction. Okay. So this is the maximum you can apply the force for which they are moving together in downward direction. What if you are applying, okay, lesser force than that, which I have already, we have done that, 192 Newton, you can have a look. Once I am applying a 60 Newton, 80 Newton, 70 Newton, we have come to know that they are moving together because friction was sufficient to balance. But to reach up to 36 Newton here, it has to be applied how much force? 192 Newton. After 192 Newton, this friction force will not balance it. Okay. So this is the things that you should know. If you are applying force lesser than 192 Newton, the friction force will be in the same direction. But if you are applying a force which is more than 192 Newton, what will happen? Okay. So if I am applying here force as 200 Newton, let us see what is the case. Okay, according to this. Okay, I will just come back to that diagram. Maybe this diagram will follow it now. Let's see. Okay. So just thinking in that same way that I have at random I have taken F like this here, and then I am going to solve like this. So here the value will be 100 Newton, okay, and this value will be, oh, I should have taken this as point F. Again I have made a mistake. Okay. So what I will do that, hello, just a minute. Have a look. If I am supplying here 200 Newton, what will happen? So there things went wrong was F here, which I have not taken as 0.6 into F. Okay, that's why I got 192, which is wrong answer. Right answer you have to follow by this method. So can you solve this for 200 Newton? What will happen? Now I have taken 200, so you just need to verify whether it is right or not. So here I have write it correctly. You can have a look. You can do it mentally also. 80 minus FW. Okay. So you can see that here once you are applying a force of total force is 80 Newton. This block will not move because this can give up to 100 Newton. So 5 kg is freezed. 5 kg is fixed. You can say not moving at all. Okay. And 3 kg. So you can have a look that it is being pulled by 30 Newton. This will provide it 30 Newton, so it will not move. So this is too large force, okay, to stick them together. But there is some force for which they are just about to slide. So at 200 Newton, you no need to verify things here. You can verify here at 100, keeping at 100, this is 50 Newton. Immediately it will give it 50 Newton. Okay, so it will stop. Once it is stopped here, 50 Newton, this is friction force here. And this is a friction force given in this way. Okay, so how much is the friction force in between them? So you can find it out here. What is the friction force given over here? Is it equal to 30 Newton or something else? Because once it is giving 30 Newton, this will be 80 Newton. So this friction force will be 80 Newton. So you need to find out here what is the force F for which, okay, they are just moving together. So now this is your homework. And just okay, this is your homework. Next time try to find out F for which they are moving together. Okay, this is the chain. Okay, and but equation is this: if answer is coming out to be negative, immediately come to this point and try to solve it. Okay.